Professor Dr. Muhammed Zeeshan Shakir from University of West of Scotland.
Thank you very much. That's the microphone is on, right? Yep. Okay. Thank you very much, and good afternoon, everybody. Thank you, Hüseyin Hocam, for your invitation to this prestigious talk. It's my pleasure to be among my Turkish friends and other friends and colleagues over here to talk about what we're doing in University of the West of Scotland. My name is Mohammed Zeeshan Shakir, and I'm Professor of Wireless Communications in the University of the West of Scotland. I am also Director of UWS, we call it University of the West of Scotland, as a digital connectivity and innovation for sustainable future. If you wish to learn about my research and want to know what we are doing in University of the West of Scotland, please do feel free to scan this QR code that will take to your website, and you will find a lot more details about our research activities and projects may you want to follow, you want to collaborate with us in future. Little bit background about my university. I'm a proud UWS faculty member in university. University is one of the most modern universities in Scotland and has 5 campuses around the UK, 4 in Scotland and 1 in England, in London down there. I am based in mainly Paisley and Ayrshire campus, which is in the centre of Scotland, and another one is on western side of Scotland. University has its history dated back to almost 100 years ago when it was a Paisley Technical College. And I want to talk about one of the first few principals, Professor Lewis Fry Richardson, who was the pioneer in weather forecast. And he published a book just after World War I, telling us about the vision that he had at that time for monitoring the weather data and making a prediction of forecast for the future data. You can see his vision, what he called as a weather forecast digital factory. You see a small image on your right-hand side there. And his vision was like whole globe or the world would be like divided into small grids, and we will have information about the weather at each grid, and we will transfer those data from one grid to other grid through those old pneumatic tubes, that transfer the information of files or documents in offices in olden days, during particularly century ago, through air pressure kind of thing. And what a fantastic vision he had that time, what we're trying to achieve as a global connectivity. And that is the title of my talk today, that I want to tell you what is the meaning of global connectivity and how we can make sure or embrace the global connectivity as we are talking about 6G and beyond wireless communication networks. A little bit more about our vision. In UWS, we're aiming to design and develop digital automation systems. And we want to use reliable, robust, and resilient wireless communication technology and solutions, including 5G and 6G solutions, that will not just improve the efficiencies of processes, but also reduce the impact on our environment and improve the quality of the life. In our research division, in our research group, we are looking into 3 themes in our research, and one of the 3 themes is a climate change. And 5G and beyond technologies has a huge potential to help us in solving these grand challenges. Another theme for our research is health and well-being, how we can use these technologies to deliver these interventions to the humanity, to the public, where we don't have these infrastructure yet available. Another theme of our research is digital connectivity for industrial manufacturing and for disaster and emergency scenarios and situations. Given the time, I might be able to talk about some of these use cases towards the end of my talk. We have been in UWS collaborating with various stakeholders that includes operators, government and public offices, industries, and et cetera, and et cetera. A little bit more about roadmap to 6G, taking forward from our research, what we're trying in GWS. I think we all are aware that telecommunication network or the wireless communication network has been now considered as a critical infrastructure for the lifeline in the countries. They are key to deliver transport, education, and health and well-being services to the public in the country. And now this is the indispensable time for the transformation of our economy, industry, and societies. Yet, we are not fully connected. I'm sure over the period of last 2 days, you might have learned some numbers and figures that 4 billion of people around the world is still not connected. I'll give you a simple example. Yet alone in the UK, there are almost 15 to 20% of the population below the 30 megabits per second download data rates, that they do not have a good quality of the internet. Those population may be in hard to reach areas, in areas where we may not have an infrastructure yet available. But there could be several reasons for that. I think one of the key reasons is the operators' availability and the revenue for them that they may not be able to get by deployment of such an infrastructure in those hard to reach areas or regions. We all know about 5G. I'm not going to spend much time on 5G and what is 5G. Ever-increasing demand of having those high data rates or mobile broadband in our handsets, ever-evolving handsets, has actually necessitated the development of this 5G network we all are trying to use or is still building. So you have learned early this morning IMT 2030 standards. There are some limitations been considered so far, how we design 6G network, taking away or building upon 5G networks. I have few pointers over here. Like using 5G networks, we have some technologies on board with us. For example, millimeter wave technology, a massive MIMO, and et cetera, and et cetera. Network densification is still growing and growing. Hopefully, we will get better solutions for the challenges that we have facing since long for deployment of the small cells yet. When we are talking about 6G network, it is important to talk about 3R approach, making them networks more sustainable. And when I say when we want to make the network more sustainable, we want to make them reliable, robust, and resilient. When I say we want to make them reliable, that means we want to make sure the 5G network or beyond should offer guaranteed quality of the service to the most users for the most time. This is really very important to understand that when we are progressing or shaping or embracing 6G technologies, are we doing right things in 5G? So I'm going to stress a little bit more around those lines. When we want to say that beyond networks, beyond 5G networks or future networks should be resilient, that means we should be able to deliver the coverage or capacity quickly in a case when there's a disaster or an emergency. When we want to say the network should be robust enough, that means network should have a capability to be agile enough to adjust its own parameters based on the user's needs or requirements, such as mobility. Let me give you some numbers that may help you understand what we should target when we're looking at 6G. You learned about IMT 2030, latency, massive connectivity, and ubiquitous connectivity, and et cetera, and et cetera. We are thinking that maybe in 6G network, we're looking at latency less than 1 milliseconds and nearly equal to 0.3 milliseconds. Very high data rates, right? We are also thinking that when we're looking into 6G networks, we want to connect over 10 billion IoT devices per kilometer squared. We also want to improve the spectral usage efficiencies 5 to 10 times more than what we could do now in 5G networks. So 6G networks is not just going to be about lower latency or it's going to be about offering better voice or telecommunication services, but it's also about connecting that unconnected, not just billions of populations, but connecting those machines, sensors, devices around us so that we can improve the efficiencies of our processes and bring better quality of the life to the general public. Thinking about 6G, I want to pause a little bit and talk about 5G use cases. So what are the 5G use cases we have? Do we have exactly industries who want to willingly adopt 5G network? No. The answer is really no here. This is what we have seen in the UK at least. When you go to industries and tell them that this is 5G network, offer latency, higher data rates, they will go far away from you. They don't have capacity to buy these networks, build these networks, automate their processes, and move from 4G or move from Wi-Fi to deploy 5G networks. So what are the real use cases that we want to exploit when we are thinking about 5G networks? And then build around them to offer reliable, resilient, and robust connectivity through 6G network and frameworks and technology. That's the idea I want to tell over here. I want to bring to your attention a little bit a UK background and a UK perspective and investment made by UK government recently. Over the period of last 12 months, UK government, a ministry called Information Science and Technology, has made a significant investment in the country for adoption of the 5G technology and its use cases. There are 10 regions in the country that has been declared as an innovation region. We have identified some sectors and applications and industries who can adopt 5G networks and then deliver improvements in their processes and efficiencies. One of that 10 region is in Ayrshire, where my university lies, and we are leading one of that region and one of that project to deliver 5G innovation for industrial sector as a use case. There are many use cases across the country in the UK which are being considered, and that include creative industry, agri-tech, food and beverage sector, industrial manufacturing, and tourism. And UWS DSIT project, where we are trying to bring industry on board, we are looking into 3 use cases. And one use case is we are deploying mobile private 5G network for industrial manufacturing, so that processes can be monitored, asset can be tracked in real time, and efficiencies of the businesses can be improved through reliable and robust connectivity without any outage. We're also looking at how we can provide the connectivity to the aerospace sector, where we want to improve their efficiencies and providing connectivity for their own processes. The project will also offer connectivity to improve the tourism in the region and improving the education for the sector. So there is a lot of use cases where we are deploying mobile private 5G network with a backhaul through satellite or a backhaul through fiber link, so that these industries will adopt 5G technology and improve their processes. There has been some lessons learned through this exercise, and I want to share maybe a couple with you over here. Like food and beverage sector, tourism sector, they don't have a capacity to adopt 5G network. So in our university, what we have done, we have created a structured program or a structured pathway for these industries to build capacity, to install capacity in their premises so they can adopt 5G networks, learn what 5G or future generations of networks could do for their businesses, and build a long-term relationships for future research and development. So that's an approach that Scotland and the UK that we have taken. And if you want to learn more, feel free to look at our website. Perhaps that gives you more idea and more information about our 5G ecosystems and 5G use cases and industry adoption exercises. Global connectivity and applications. Now we can deploy number of sensors wirelessly, not tethered at all, almost anywhere. I'm sure you all have been learning about IoT and AI applications since morning today. Some NTN perfect applications, I think, were discussed just before the lunch in the panel. And I just want to stress over here, in order to collect that information, we would require a global ubiquitous connectivity. Not necessarily low latent or high data rates, but we would require a global connectivity, a ubiquitous connectivity, a no or zero outage, so that this information can be collected wirelessly from anywhere and can be delivered to the sector, delivered to the services, where you can apply AI algorithm, train AI algorithms, and create some alert. I have some examples over here. I'll briefly go over with them. For example, immersive technologies can be used over high data rate applications to be anywhere without being there physically. Ultra-reliable, low-latent communications can be used for devices to deliver predictive healthcare facilities for vulnerable communities. Similarly, you can deploy massive machine-type communication to monitor air quality or monitor the environment or the key services in the public sector through satellite or through terrestrial networks, so that some early interventions can be delivered. United Nations has launched 17 Sustainable Development Goals. We call them SDGs. And I believe that 5G and beyond technologies, covering what we have discussed over the period of last 2 days over here in this brilliant conference, has a huge potential to solve some of these big challenges that human history, I think, never faced before. Climate change, I think, is one of the biggest challenges. And you can see some of the examples that I have over here, that how we are using 5G and IoT together to solve some of these challenges. I just want to briefly mention about a project with a company called Phytotech, where we are using LoRaWAN and NB-IoT, both type of connectivity, to deploy sensing technologies that we have designed and developed with the company through our research to detect the water leakages in underground water pipes. The work has received numerous awards, and it was featured in BBC last year. I'm not sure whether you have watched that, but if you have a chance, if you have interest, please feel free to look into our website. You may find the documentary there. Moving forward, it is expected or anticipated that in next 10 to 15 years, the world will have more than 40 megacities. In those megacities, we are anticipating there will be more than 10 million inhabitants. There are bigger problems, as I said earlier, that we need to make sure these cities are safer and they offer the services to their residents, right? But the infrastructure, telecommunication infrastructure, is a lifeline to these megacities. We need to make sure that there is a connectivity to offer the public services, health and well-being, and safety to the wider residents in the cities or in the countries. There are two challenges when we talk about the infrastructure. As I said earlier, a small cell has been considered as one of the key architecture enabler for densifying the networks. But this technology of a small cell is not new to us. We have been talking about it since 4G, I would say. But the challenge with the small cell has been still with us. That's the reason that we are unable to adopt a small cell at a wider or larger scale. And one of the challenges that we face with the small cell is a backhaul, the deployment of the small cell itself. There are two options we have in front of us. We want to deploy fiber for these small cells, but that's quite expensive, but good for data rates. We cannot dig the earth or trench, everywhere in every corner. And that solution is quite expensive itself because the cost of the fiber to deploy or to maintain is being costed as per unit distance. Another challenge with the wireless solution, we have very limited spectrum, microwave spectrum, for example, for small cells as a backhaul, a lot of interference and a very low data rates. So these are the challenges that we have. And those are the barriers we have to densify the network with the fixed small cell that we have been deploying successfully, but there are barriers that we yet to solve. So I'm going to put a case over here. How about we exploit airborne networks to solve some of these challenges? This is what we have been doing in our recent projects. So let me quickly tell you, I'm sure over the period of, I think at least this morning, you all know what we are talking about, NTN networks. NTN networks includes satellites, LEO satellites, and also airborne networks like HAP, MAP, or medium altitude platforms, or UAVs, or tethered balloons, and et cetera, These flying platforms or flying balloons, they are flying or positioning themselves in quasi-stationary positions. They're not moving all the time. They may let self in a nice position where they can offer the connectivity. They come with the transceivers, different types of the transceivers, and provide the connectivity to the terrestrial devices. There are a variety of these examples that are commercially available to us, and perhaps that is the reason that these use cases are getting very popular these days. Small cells tick many of these performance criteria. For example, when you deploy small cells, it can be deployed closer to the users. You will have a better line of sight probability. You can solve some of the mobility challenges, but the location is fixed, not much flexibility that you would have otherwise. With the UAVs, remember I'm talking about those UAVs which are flying much closer to the ground, not LEO satellites, right? So these UAVs are flying very close to the Earth, for example, a few hundreds of meters far from the ground, and and they are just like a flying small cells, right? So they're flying very close to the ground so they can go wherever they can or wherever there is a need of a coverage or requirement of the coverage to deliver the capacity or the coverage. So these UAVs, in addition to that mobility and line of sight criteria, may be able to provide better backhaul and a better agility and resilience. For example, in a case of an emergency or in a case of the disaster, these UAVs can quickly fly to the not a spot area and deliver the coverage or the capacity. You might have seen those big drones, I think, earlier during the panel. Industry made some presentations, and those are the perfect examples how you carry these transceivers and deliver the coverage and capacity in the area where you have a not covered, or you have a not spots there. We believe that these airborne networks are part of wider NTN networks, non-terrestrial networks, and in non-terrestrial networks you have LEO satellites, and you have a HAB, LAB, or MAPS, and you have a terrestrial nodes there down at the bottom. These physical, the closest most layer, the closest layer of the airborne network, which is close to the ground, can be considered as a physical layer, for example. For example, flying as a base stations or flying as in small cells. They can fly as close to ground as few hundred meters. They are not necessarily flying. Perhaps they can latch themselves at the top of the building and deliver the coverage. There could be a top layer, HAPS, for example, flying at an altitude of 10 kilometers, provide the backhaul to the rest of the layer. And there could be a middle layer that relay the information between lower and a medium layer, right? So you can envision these NTN in a layered architecture where airborne network and a LEO satellite and a terrestrial network converged and integrated to offer the guaranteed quality of the services, or the idea that I shared earlier about the resilient, reliable, and robust connectivity. The NTN has been getting, or the airborne network has been getting very popular. And one of the key reasons what we found that there are manufacturers who are designing, developing, or making them available in the market. There are quite a variety for us. So what we have done over here in this chart that you can see, we have classified some of these flying platforms into various categories. Like some of them are suitable for flying closer to the ground, but some of them are suitable to flying at a very high altitude. And that may be depending on the battery life, endurance, the payload they can carry. So there are various characteristics, there are various performance matrix that you can consider before you want to bring them on board and use them for the NTN or the network coverage or the provision. I want to now present two use cases in front of you. So one is that how these NTN or airborne networks can offer a backhaul for the small cells. So the idea over here is that these flying platforms can be deployed as a backhaul in a high density of small cell areas where you do not have a coverage, or it's broken, or it's hard to reach areas, in order to ensure that the small cells can offer connectivity to many users, or offer the reliable, guaranteed quality of the services to the many users. There are various advantages. It could improve the reliability in the network, the guaranteed quality of the services. Imagine the small cells already had the limited backhaul. The wireless backhaul that we're operating right now is a microwave, for example, or if you want to use fiber, that may not be available everywhere. So how about we talk about these UAVs flying at a little bit higher altitude, just more closer, not like a Starlink or LEO satellite, talking about a 10 kilometer far from the ground, and they can provide the connectivity to the small cells. There are challenges, of course, that how you deploy them and how do you integrate them with the rest of the airborne networks. For that, we can maybe use artificial intelligence to design some transport layer protocols, intelligent transport layer protocols, or routing protocols, learning some states about the traffic and divert the package of the data information wisely and intelligently. I want to just focus on one framework that we have proposed 2 to 3 years ago, and the work received some award from IEEE Communication Society, Fred W. Lersig in 2021. In this framework, what we have said, these flying platforms would fly at an altitude of 10 kilometers, a little bit higher than what you would think otherwise, exactly at an altitude where you commercially fly in an aeroplane, actually. And the reason behind choosing this altitude is this region is particularly more turbulent free, less cloud. So that's why you can let these drones to fly. These are bigger aeroplanes, I would say, fitted with their own solar panels and transceivers and FSO transceivers. So they actually create these FSO beams for the small cells on the ground. And in just 2 hops, they're able to provide the backhaul connectivity for those hard to reach small cells and offer the connectivity and a backhaul. There are various companies in the market in Europe right now. They are manufacturing these type of transceivers. They can be easily fitted at the bottom of the nose of aeroplanes, for example. Boeing and other aeroplanes are now being considered as one of the potential use case to test and fly. With FSO, I think many of you, if you have ever learned about FSO, there are challenges. For example, fog or other weather conditions. We have considered all those challenges when we have done the link modeling for the FSO link. I'll just skip that briefly and come to the results. As you might thought that FSO could be a challenging issue for this link, particularly between the small cells and the UAVs or the flying altitude platform, which is not the case here because these links are vertical rather than horizontal, right? In FSO, for example, the fog is an issue. What we have noticed, fog alone is not maybe an issue. Fog plus other weather conditions could cause a trouble for that particular link. And another thing, what we have noticed that because the link is going vertical from ground to the sky, a part of the link only gets affected due to the fog. You can see over here, there's of course delay. You can decay over here in the data rate that we get. On an x-axis, you will see the altitude where we could fly these flying platforms. On y-axis, you will see the data rate that we get. The black curve, of course, looks pretty decent. Over here, that offers gigabits per second, a higher data rate, even at an altitude of 20 kilometer high. But if you see, as you go down the blue and red curve, they are getting lesser data rate and poor link margin because of the combined weather effect due to heavy rain or the cloud and etc. In our simulations, we have considered various environmental and losses. For example, pointing loss, geometric loss, the energy, of course, you will lose the energy as it spreads from the transceiver to the receiver. So we have considered all those factors. We have also considered environmental losses. We have considered the losses due to cloud. We have modeled that as well. So if you are interested in learning more about this framework and learn how to calculate all these losses, feel free to look at this particular paper that may be able to give you an idea how all these calculations ended up with these results. We have also calculated some costing of this solution, right? So we have compared this solution that what we have said, the UAVs are flying at an altitude of 10 kilometers with the other solution that exists in the market. For example, to the comparison with the microwave solution that we have right now and compared with the horizontal FSO, where FSO beams connects transceivers in a horizontal manner. So what we have seen, for example, the first curve, of course, you will see where you have a non-line of sight solution. This is one of the cheapest and the best solution, I would say, in terms of the costing, but there's a major cost associated with the spectrum licensing. The next solution, the next bar you will see, there's a huge blue chunk. That is a fiber solution, and of course there's a huge cost rate to the fiber in terms of the cost and in terms of the operational expenses. The solution next to it is a terrestrial FSO. Terrestrial FSO means you are deploying the FSO in a horizontal link. That means if there is a fog or if there is a poor link, you might need to install more transceivers. That means there will be a more cost for the equipment, and that's why you see the huge blue chunk costing element for the cost of the transceivers itself. The last, which is our solution, where you see a huge amount of the yellow part over there, that is the cost of the maintenance of these flying platforms. And you can imagine these platforms are quite expensive when you run them. They're quite big and they have energy panels on top of them. And we have assumed quite few they are flying in a simulation scenario. You can see these details in our paper and our publication. But the idea over here is that these solutions are expensive because you're considering the cost of that big aeroplane and transceivers and everything. But there's no cost of a spectrum and there's no cost of the maintenance much there. But the cost will go down, as you can imagine, with any technology which is new with the application and the widespread adoption in future. I will now move towards a second case where how this airborne network or UAV can serve as an access network in areas or in scenarios where you have an emergency. for example. So the idea here is that we deploy UAVs as a base stations, as a flying base stations, to densify the network where you have either congested or a damaged base stations. So idea here is that we want to improve the resilience in the network. For example, you have a broken base stations, or you have a disaster or emergency situation, you want to order a coverage or a capacity, so drones will fly quickly to the area or a region and then deliver the capacity or the coverage to the particular user or the set of the users. There are challenges, for example, how quickly you can go, what is the trajectory look like for these UAVs you can go, and where they should place themselves, what are the constraints they may have at the physical layer, that how many users can get connected to the base stations, flying base stations, and how many users can get the guaranteed quality of the services. So those are some challenges that we may want to study, and we want to share some results with you. Graphical illustrations, how these UAVs can fly, scan the radio environment grid by grid, and then find out what are the coverage holes that exist based on the measurements that they make, and then deploy themselves as a base station in those coverage holes to provide the connectivity. In one of our approach, and the results are published in this particular IEEE transaction on machine learning, you can view these results if you wish to study more about that. What we have done, one of the challenge that I said earlier is where to place these UAV. So what we have done, we have predict the user's mobility. So we have applied some federated learning approach, distributed learning approach, and LSTM, long short-term memory models, in order to predict the user's mobility, where they would go next, and if they fall into an outage. And if that is an outage they get into, then we will deploy the UAV as a base station to deliver the coverage to those users. So this is a distributed learning approach. So each cell will run their own models and know the location of the cell IDs and handover times. Is a kind of a typical sequence prediction problem, and we have applied LSTM over here to predict the next cell for these users and to find out where they would go next. And once we know that, we deploy the UAVs as a potential placing positions for them. Some simulation results pretty interesting over here. You will see as you move clockwise from left to right, you will see that some of these users with the unique IDs are moving at different time stamps. So they were associated with, for example, if you follow user number 7, they were associated with base station 1 at one time, and after a few seconds or minutes, they are associated with the base station 2. At another time, after a few minutes, they are now associated with no base station. That means they are under outages. And you will see them over here, that some cell number, user number 27, for example, 26, for example. So these are the users which are not associated with the mobility. So we have predicted the mobility of these users using this LSTM approach, predicting the next cell. And then we identify this area as a coverage hole and deploy base stations to deliver the coverage for those users, which is much effectively. And you can see over here when you deploy the base station in the last short, in figure D, last screenshot, where the users are now connected, that means that improve the overall data rate for these users. And that you can see over here, just before UAV and after UAV downlink average rate that you can see over here. The blue one you can see as much lesser than the yellow one that you can see. So the users are now connected and not into an outage. That means we can offer a better, a reliable, guaranteed quality of the services for many users for most of the time. Just another illustration for resilience in the network. You can see over here the number of the users with our approach, which are seeing the outage is much lesser than the other approach that exists in literature, where they are not using LSTM approaches and predicting the UAVs, predicting the user's mobility and deliver the coverage, so which is much better in the sense that less users will fall into the outages and provide the guaranteed services to many of those users. So this was the challenge number 1. The another challenge, and pretty much last few slides perhaps for me, that how do we deliver these coverages to the users? What we have seen in the literature, that when you want to deliver the coverage to an area where you have a congestion or you have a disaster or you want to bring UAVs as a flying stations, you need to know the obstacles, right? Where they are, how they look like. This is what most of the literature has done. So we want to find out that what if we don't know the environment, what we don't know the radio environment, and what we don't know about the obstacles, then how do we deliver the coverage? And what are the challenges that we may have due to the batteries? You know that UAVs, they have a very limited amount of the batteries, so they cannot fly unlimited amount of the time. So we need to consider these two factors when we design their trajectory in order to ensure that they will deliver the coverage or the capacity in a region or an area where it is required. So what we have done, for example, if you want to go from position A to position B, and there are obstacles down there in your trajectory, and you want to know about their channel state information so that you can learn about the environment, the radio environment, and then somehow you want to know the location of the obstacles so you can avoid in your journey. You can let the drones avoid these obstacles before they reach the destination. So we have designed a kind of a hybrid or a combined algorithm that use CNN, convolutional neural network, that captures the spatio-temporal dependencies in CSI, okay? And then classify the obstacles from the heat map. Once you classify the obstacles in a heat map, then you apply LSTM, long short-term memory models, in order to predict the obstacles where they are, so that you are able to fly the UAVs from one point to other point without any collision and in the shortest possible way. What we have also considered in addition to that, the battery time that drones may have. So we have considered that given a threshold X available to the drones and learning about CSI from these heat maps, they can avoid the obstacles and fly around the obstacles, and they can reach the destination given they have an X threshold of the battery and enough time to return to recharge the battery or to exchange or swap the batteries before they reach the destinations. So these are the important practical considerations we might need to consider before we deploy airborne network for coverage or capacity considerations. We have compared our CNN and LSTM-based proposed approaches with existing machine learning and reinforcement learning approaches. And what we have found, it's quite shorter time for us. Like, for example, with one or two or fewer obstacles, we could reduce the time from up to 20 to 30% in the delivery of the coverage or the capacity for these UAVs. That means improving the resilience in the network. That means quicker we can deliver through these AI-enabled trajectory planning or the coverage and capacity delivery approaches. With this, I just spent maybe a minute or so on some use cases. As I start my talk today, I talk about applications of 5G or IoT networks for climate change. This is a project funded by UK NIHR agency, National Institute of Health Care Research, which is our national funder. We are receiving a funding from this funder for a collaboration with South African partner to deliver 5G and IoT-enabled network, a solution that would not just predict the flood in an extreme environment, but also deliver a disease outbreak for the vulnerable communities and first responders to manage the operations better and effectively. It's a 2.3 million funding that we have received and is a program between Scotland and South Africa to run from next 4 years. If you want to learn more about this, feel free to look at our website. You may be able to learn about that. But this is kind of a real application that how these global connectivity concept could help us making our world more safer and inclusive for everyone. I think I talked about this earlier, but I just skip it, that how IoT, NB-IoT, or 5G networks could ensure the climate challenges, water security. If you want to learn more, just feel free to learn it, but in the favor of time, I'll skip that quicker. If you have a question, I'll be able to take that. Health and well-being, we have deployed NB-IoT solutions in an indoor building and outdoor environment to monitor the environment and deliver some health preventions. So these global connectivity perspectives has allowed us to connect a variety of the data so that we can find some correlation and underpin those existing relationships between the data and environmental parameters that never understood, that never studied before. For example, an environment could be harmful for your health and well-being. you could be in an environment for long term, then it could cause a kind of a long-term disease and create an impact for you. So we have studied these kind of applications for digital connectivity and global connectivity, and looking into some other use cases as well, which are there on our website. If you want to learn more, please feel free to visit our website. In conclusion, I just want to repeat what I said at the start, that flying platforms or airborne networks, they have a potential to improve the reliability and resilience in our network. For example, they can go quicker to the areas where you do not have a coverage, or they can deliver the capacity when the infrastructure is broken or compromised. However, artificial intelligence and machine learning and new approaches can come together and get integrated into AI, enables UAV or NTN systems, so that they become more advanced and modern when we are trying to solve some of these challenges. I'll take a moment to thank entire team. Some of them are in the picture, some of them are not, but my entire team has been working very hard over the period of last few years to deliver results that I just talked about. It's just the teamwork, what I just talked about today before. And these are some of the awards that we have received. With that, I would like to thank everybody for your listening.
Okay, so Sohaib, we start with you. By the way, Zeeshan, this is a great work. I mean, you are not just doing research, but you are helping the society. I mean, I really like this kind of research. You know, you don't just publish papers. I mean, I'm seeing a lot of papers that you are publishing, but I think more importantly, the impact that you are making in society is great. I mean, I thank you very much.
Thank you very much.
Go ahead, Sohaib.
So, Professor Zeeshan, my question was, you mentioned that even in UK, the adoption of 5G in terms of use cases is very limited. And even for that, the UK government is taking a lot of steps to incorporate or realize those use cases. So one thing I wanted to ask is this, what encourages us to think that this would not be the case in 6G? Like the industry would be willing to do the adoption on their own? And if they won't do that, do you think it's sustainable that the government does that thing again, that even for 6G, they take the brunt of the economic cost to deploy those networks in the industry? So that's the more futuristic question. And the second, I just wanted to ask about the FSO for backhaul UAVs that you talked. So are those studies still in simulation based, or do you have any experiments related to that?
Okay, thank you very much, Suhaib, for that question. I'll answer your first question first, okay? So for 5G, there are two use cases, okay? So one is a real use case, and another one is useless use case, right? So honestly, there's been a lot of discussion going on that what are the use cases that we have for these technologies. And we really had a hard time when we are trying to, or we are still actually trying to convince the industry to adopt 5G, not manufacturers or operators. I'm talking about the beneficiaries of the 5G technologies. And that is not happening, it's still not happening. I don't want to discourage people thinking about 6G network, but I just want to be like, take a pause and think about 5G use cases first, and then build around that so that we can offer the services and ensure that engagement and ensure that adoption is there and there's a progression. So your question was that how we bring industry on board when we're thinking about the use cases. The use cases that you have seen over here, these are the some use cases. We are still shaping up in the country, in Scotland, for example, how we bring the use cases for the industry. And the key idea behind and the key framework to do that is an engagement. Industries or the beneficiaries were not on board when we were setting up the latency requirements, like URLLC or massive machine type deployment or enhanced mobile broadbands. The beneficiaries, real beneficiaries, SMEs, food and drink sector, for example, tourism sector, they were not consulted before. So nowadays in Scotland, I'll tell you what activities going on. There are colleagues from the rest of the UK, maybe they can answer that question better. In Scotland, we are creating a 5G ecosystem in the country, right? 5G technology is there. In the UK, we have launched the 5G technology in 2019, right? It's been 5 years now, but it's sad to see it's been not adopted by the sector. So what is missing in the fabric is the ecosystem. Ecosystem is something that bring all the stakeholders on board, right? Small SMEs, big vendors, beneficiaries, council operators, users. They all need to come together, identify their challenges and need. And education, as academics and as scientists, our role is to translate the impact to everyone so they can understand the benefit. Everyone can get, there's a thing for everyone, I would say. Councils can improve the benefits for the general public. Industries can improve their efficiencies, target those actions that they want to target. So that didn't happen in past. In Scotland, it is happening right now. We are creating those guidelines. We call it a 5G ecosystem, honestly. And that is there to adopt any technology beyond 5G. And when 6G comes in, we will use that framework and then adopt. So that engagement, stakeholder engagement, is a key here to shape the use cases. Some of the use cases that you see over here, tourism, agriculture, manufacturing, we ended up with these after several consultations. But within that, what actually we would be doing? Should we use immersive technology? Should we use IoT for asset tracking? What is the need for 5G? We don't need a latency there. We just need a ubiquitous connectivity, right? So those needs, technical needs and requirements are yet to define when we're talking about 6G. So I just want to say my message was that we need to be mindful when we're talking about 6G, bring that reliability, resilience, and robustness in 5G network, and then shape up 6G network around that. Your second question about FSO, our study was based on simulations. So we have done the simulation based on the length that we have considered across the platform. For example, 10 kilometer was the length we have considered, and we have assumed there were length across which rain, fog, or other environmental parameters could affect the link budget, so you can see the data rate or the link margin outcomes that you may have. I hope it helps.
Zeeshan has a flight, actually. You can only make it now. So if you have any questions, you shared your email address, right?
Yes, I did share my email address and a QR code, I think, at the first slide, but it's not that difficult, I think, to find me if you Google.
He's not even using his classical email. QR code is going to solve.
But thank you very much.
Thank you.
Thank you. Thank you.
It's an honor to have you here. Keep doing what you are doing. I mean, it's really impressive. And we'll see you next time, maybe, with more time allocated to you.
Yeah,
so
thank you so much.
We have a gift for you.
Also kind of you.
And maybe our president can also provide the gift to you before you leave. So you're going to get the gift from the head of BTK.
It's my pleasure.
His father studied he did his PhD in Glasgow as well. Okay. Okay. All right. Thanks again, Zeeshan. It's always good to have you here in Istanbul. And by the way, ICC is going to be ICC, right?
Oh, yes.
Yes, ICC.
I can make a quick announcement, actually.
Well, I will do it. You just run for the flight. So in 2 years, 2026, right?
2026,
yeah. They are chairing ICC, and I'm sure.
Looking forward to see some of you there, and including Professor.
Okay. All right. Have a nice
so
flight.
much.
Okay.
Thanks,
Okay. So now our next speaker is somebody that especially the young guys know very well. He's the most famous researcher in LinkedIn, in social media. I end up meeting with him actually about a couple of weeks ago in Valencia. We had a good time. But I was always wondering, who is this young man? I mean, like, in this young age, so active, so, productive, publishing, social work, and also, editor in magazines, special issues, everywhere. I mean, you see him everywhere. So that young man is now here in Istanbul, okay? He's going to deliver a speech. And I always share my pictures like here and there, but those are like pictures of 20 years old, okay? I thought this is the same guy. I'm like just using his young, pictures. And I was expecting like somebody like 40 years old, 45 years old. I was surprised actually. All right, Aryan Kaushik is our next speaker. He's from University of Sussex, And Aryan, thank you very much for coming. And probably half of the audience are here for you, just for you.
Thank you, Hüseyin. Thanks a lot for such a nice introduction. I couldn't describe myself better than that, actually. And thank you so much, everyone, coming in this afternoon session. So I think I was 15 minutes delayed, so I hope I can use 10, 15 minutes with extra time. So I am Aryan Kaushik, and as you can see on the screen here as well, so there are a couple of links I've given to sort of my website. So if you're ever interested to sort of collaborate and work together, or just interested in my research after the talk, please feel free to go through any of these. So just a quick thing about me. So actually one news. So I'm moving from University of Sussex to Manchester, Met in the UK as associate professor, and I've had a little bit of background here and there, and also a lot of like speeches here and there. So you might have heard me somewhere speaking about some of the things. I've been a bit of editor, a lot of areas that I also do research in. So ISAC is one of the main topics. Then we are also trying to figure out about electromagnetic signal information theory, non-trusted networks, our work quite a bit, and then also some sort of applied AI, machine learning, and so on. So several of these areas that you can see I've been working on. So just a quick thing about me, and I've been quite active with other activities as well. So no need to mention everything. So I will go into the topic. So as we can see here that what we are actually expecting from our 5G subscription. So you see that in Turkey we are still in the need to deploy 4G. LTE is there, but we need to deploy 5G, right? So 5G and 5G advanced. So perhaps this will be the sort of key technology that will come. Okay, we are talking about 6G, but I do think that in Turkey, 5G advanced will fulfill several of the requirements that we may need, and we are expecting the way forward in Turkey itself, right? So what we see here is that if you look at many of the industry reports, so 5G subscriptions, better than 4G or 4G LTE, better than previous standards, let's say, are growing at a faster rate. So as you can see, that about 5.6 billion of the subscriptions, 5G-based services, by 2029. So this is a big number when you compare with, let's say, the previous generation standards. And just in Western Europe, you will have about 560 million subscriptions, just as a sort of case study, right? The idea that we have about 5G in mind is that we stick to 3 use cases, as you can see on that particular triangle on the left-hand side, right? That you have enhanced mobile broadband, ultra-reliable low-latency communication, massive machine-type communication. So this is the triangle that we had, focused most of our research and development activities around, right? When we were talking about 5G. So IMT 2020 that we were talking about, right? Then in 5G Advanced, we want to stick to the same sort of triangular framework, but advance those technologies, right? So keeping these technologies that we have in 5G in current infrastructure that we have, but advancing them. Maybe come up with more massive IoT connectivity, try to come up with more energy efficient solutions, which we are lacking, let's say, in 5G itself, right? So that's the idea of 5G Advanced. But my point of touching this slide is that we see that even if you deploy 5G Advanced, it is a better advancement over our previous generation standards. But when 6G comes into picture, things change a lot, right? So basically, you are not just sticking to this triangular framework that is in the middle. You are playing around with the hexagonal framework. So you're adding up some enhanced capabilities. You might have seen this figure numerous times, right? So the idea is that we advance over our current infrastructure, but we add up, additional things. We have enhanced capabilities. So what are those enhanced capabilities? So you have 3 blocks, as you can see here. You have integrated sensing and communications. You have integration of AI and communications. So basically come out with multifunctional approaches. So you don't have to use a sensing equipment separately from your communication equipment. This can be only one device. Your mobile phone can be also sensing around you. Your driverless car can be also sensing and also communicating the information, right? So it makes it more multifunctional. Then you can also put this on the same device, share the same frequency resources and so on, and also utilizing some other fields. So let's say AI is something that has been going on, let's say, for another, sort of 10 years, at least the applications of AI into communications. So to integrate this AI, these automated methods and algorithms, optimizations and so on, into our communication models, right? And also using communication for AI too, so in over-the-air computing or many other applications that you can think of. And then also one addition is ubiquitous connectivity. So you have heard NTN a lot today, so non-terrestrial networks is a very good example of ubiquitous connectivity. So it says anytime, anywhere, anything sort of connectivity, right? That you're able to connect the unconnected. So basically the rural areas, remote areas. I live in London, so sometimes I don't have any internet in the subways. If I'm going to Kent or Surrey, I don't have internet. So to really get rid of these problems that we have with our current infrastructure, the base stations are not able to reach each and everything. And especially when you are in a city like London, you have, or in Istanbul, let's say, you have so many people to basically serve on your infrastructure, on your services, right? So it becomes a major problem. In these scenarios, you can implement non-terrestrial entities, your drones, high altitude platforms or medium altitude or whatever, different categories, and then also get the direct access from your satellite to your smartphone. This becomes very important. And again, this is not a new technology. It has been in talks from 90s or even before that to be included into our mobile networks and cellular networks and so on. But keeping many challenges in mind, this will be one of the vital technologies when we talk about 6G, when we talk about implementing 6G. And many use cases, so you can see different circles here, many use cases are here in smart healthcare, robotics, in massive IoT systems, in indoor facilities, outdoor facilities, and many of these you can really think of. And we also need to think about the sort of the standards that we have, right? So we know the framework, we have the consensus as a community that we will work around this hexagonal framework. So not just touching the triangular framework that we have had with IMT 2020, we are also going to work on enhanced capabilities, right? But at the same time, we need to freeze these technologies as well, right? The standards around these technologies. As you can see the evolution, we started with something very basic things. We had sort of analog-based communication, then we moved to digital, then we had sort of hybrid communication-based services, multimedia came in, faster speeds of the internet came in, so we had to standardize all these, right? It's not that you are just working randomly. So there has to be consensus in the community that these are the technologies that are frozen and you'll be working on these for next couple of years. So if you want 6G to be in your phones by, let's say, 2030, you need to freeze these technologies by 2027, let's say, so that industry and academia and everyone can actually work on these. So this is a very important point. So as you see here that, we have had recent releases, so 17 and 18 have been wrapped up. So the idea was to include advanced methods and technologies, right? So you have orchestration of your networks, management of your networks, RAN slicing and whatnot, network slicing, many things that you have in release 17 and 18 of 3GPP, right? NTN was also introduced in release 17 as part of this ubiquitous connectivity sort of ecosystem that we have. And in release 17, you see here is also machine learning, edge computing, all these things are there. So the idea is that you are going hand in hand. So whatever you have been deciding for your 6G or IMT 2030 framework, that is also being put into standards. So that's the biggest key takeaway that I want to project from these slides. And then now in release 18 and 19, right? So release 18 work is going on, 17 has been wrapped up, if I said the other thing. And release 19 has also been decided, right? So what will be the study items in release 19? So we'll be working around advanced MIMO solutions. Becomes very important that not just your gigabits per second capable speeds, you're coming up with terabits per second capable speeds. So your devices have to use next generation MIMO technologies to basically increase the capacity as much as possible. To make things cheaper, of course, you need to make it energy efficient, but at the same time, you need to increase the capacity as maximum as possible, right? So massive MIMO need to work around this. You can come up with some fancy term, holographic MIMO, let's say. That can be also there, that you are producing a holographic output. That is also important. But the idea is that you need to work around MIMO technologies as well. High mobility scenarios, whether you have drones, your satellites all moving, right, in the orbits or in the sort of HABs or labs or maps, whatever you're talking about, or your driverless cars or your any vehicular communication that is there. everything is mobile, right? So even yourself, you're mobile when you're moving, your phones, your devices, everything is mobile. So to really accommodate that high mobility, that is also a part of the release 19 for 3GPP. Then again, we continue with AI, machine learning, and their applications, especially for RAN, Open Radio Access Network, or just RAN as well in general. Extended reality, immersive communication is very important. So again, you might be using these Oculus headsets or this, Apple VR headsets and so on. So they still need a lot of improvement in terms of graphics, in terms of communication, in terms of the latency and so on. So we need all these, and these are included to be studied into release 19. Energy efficiency is one of my favorite topics, is that you need to make this cost efficient. Our 5G based devices, even though we had these initial standards in 2019, 2020, 2021 in UK, were not very energy efficient. So it has to be energy efficient as well. Then non-trusted networks, again, we continue with that technology. And here, so I don't know why it's like this, but we have one sort of star of the show is joint communication sensing design. So you have addition of this topic into 3GPP release 19, right? That how to co-design sensing and communication. So you can come out with, let's say, I don't know, coordination between these two. So you can have your sensing equipment at the corner of this room. I can have my communication device, my mobile phone. They can be coordinating with each other under one network, like sort of WLAN sort of setting, right? Or I can have the same device acting as a sensor and a communication device. So my mobile phone can act like a sort of mini radar, and also a communication device it is already, right? So you can have them on the same hardware as well. Then you need to play around with how to design the intelligent waveform for these, how to really make the data processing, the data volume handling very efficient, how to make it cost efficient, because you're trying to put in two functions all at the same time, simultaneously, right? So you want to detect the, sort of monitor the environment, at the same time you want to communicate. So it becomes very important that you come up with very, very advanced solutions for this, right? And there have been some early study items that are considering communication-assisted sensing and sensing-assisted communication. So basically your sensor can be your main task, right? But communication is just assisting that. In case you extract some information, you monitor your environment, and you need to pass that information somewhere. So communication is just complementary, right? Sensing is the main task. Or you can go the other way around, sensing-assisted communication. You have communication as the main task, sensing is just complementing that. Here we have a bit of difference of opinion with industry. So these are the industry study items, right? The standard study items. In academia, we are working more on the trade-offs, the tunability of these two functions, right? So basically, because we guys are a bit dreamy guys, and we like to approximate things, so we can approach this tunability factor quite much. But industry is picking up very initial things, right? So we need to keep that in mind as well, that we are aligned with industry development as well. And there have been 32 industry use cases, smart healthcare, robotics, IoT, many use cases that have been predefined in this aspect. So when we talk about the 6G framework, we talk about the standards, we also need to remember that what kind of spectrum we are going to use, because this is a very limited resource, right? Especially when you're talking about, I don't know, let's say a country like UK, for example. So there, or in the US, you have to actually decide what kind of, allocations that you will give to your spectrum, to your, service providers and so on. So for 6G, what we are thinking, it will be centimeter waves. So your low to mid-band spectrum, right? Because the idea is you do not want to move too much far away from your current sub-6 GHz frequencies. So do not want to move away from microwave spectrum, right? So you could see many commercial applications. Apple was doing it, and some other companies as well, on millimeter wave, using some unlicensed bands and licensed bands and so on. So there were some commercial applications, but there is the danger, there is the risk of ending into sort of path loss effects, blockage effects, and so on. So let's say if I pass a millimeter wave from here, this side, I shake my hand here, right? The wave is distorted. The signal is gone, right? So it is distorted. So to avoid these scenarios and still have to be able to use the same sort of technology that you were using for 5G or 5G Advanced to deploy on similar frequency as sub-6 GHz band. So you are going to use 7 to 8 to 9 to 10, 11 gigahertz sort of frequencies, up to, let's say, 13, 14 gigahertz. And we see a lot of existing applications already, right? So basically you have, you're using some radars at these frequencies for, I don't know, weather monitoring, air traffic control or some sort of maritime security and so on. So many applications are already there. So when we are talking about integrating sensing and communication, it becomes a bit easier for us because we already see some existing applications. So this will be the key enabling spectrum that we are thinking when we are talking about 6G. And we also need to keep in mind that we are also trying to use higher frequency bands as well. So again, it's a debatable point. Many people might not agree. But you will use, let's say, sub-terahertz bands beyond 90 gigahertz, beyond 100 gigahertz and so on, basically at some geographical locations. You will not require these high frequencies everywhere, wherever these are mandatory to use, right? So you'll be using sub-terahertz bands. And again, you can see some existing applications like automotive radar and so on, about 77, 80 gigahertz frequencies. They are already using this. So the idea is that you're trying to explore different bands. Again, it does not stop us from exploring terahertz bands, but as far as 6G is concerned, sub-terahertz would be more like a complementary spectrum, and centimeter wave will be key enabling spectrum. That's the sort of direction we are heading into. And we have done, several sort of, works around this as well. So one of these works is very recent one with NYU guys in US and NTT guys in Japan as well. So we try to work out what kind of different scenarios there can be when we try to implement centimeter wave and sort of sub-terahertz frequencies, and different use cases you can come up with as well. So if you're really interested into knowing more how to deploy ISAC or some technologies like that at these frequency bands, I would suggest to you go through this paper. And going into these, let's say, more technological sort of discussions. So again, as I was saying, that ISAC is one of the key blocks when we talk about the 6G framework, the hexagonal framework that we have. And the idea is that you are sharing the spectral resources and sharing the hardware as well. So this becomes a very important technology because you want to decongest your existing with spectrum, which is very congested, right? Or you just want to have multifunctionality of your devices and equipments, but in a way that they are efficient as well. So first of all, cost efficient is one of the key points. So this technology seems quite important. And again, I have given really a lot of links to our papers, and I also edited a book very recently on ISAC. So we have about 16, 17 chapters, and you can see all the experts that are well-known names in ISAC. Most of them are in contributing chapters in this particular book. So if you're really interested to know what has been happening from industry point of view, from academic point of view, this is a good reference point, right? We also talk about channel modeling and so on, which I did not discuss in 3GPP release 19. Channel modeling is also one of the key points when it comes to ISAC. So there are two sort of case studies I would like to touch very quickly. So again, I will not go into very detailed sort of information, but the point here is that already I see that ISAC is already quite efficient, cost efficient, because of sharing of the hardware resources and spectral resources. Can I make it even more cost efficient, right? Even more energy efficient, let's say, to be precise. So here, for example, just the case study I would like to touch. So let's say if you're trying to use some beamforming method, like a hybrid beamformer, for example. So generally, let's say if you will go to your FPGA manufacturer, he will give you, let's say, 64 antennas at the transmitter to be able to transmit the signal. And he will give you about 32 RF chains, let's say, when you're talking about hybrid beamforming, right? Because you're using sort of conventional beamforming, but you're adding up some phase shifters and some sort of analog precoding as well, as you can see here. But you don't need to use all these 32 RF chains. I want to plug in some sort of selection framework, some sort of algorithm there into my FPGA, right? To basically give me a good number of RF chains, or the quantization units. So instead of using all 32, I would be interested in using 4 or 5, let's say. So it depends on how intelligent is my algorithm to basically give me that solution, right? So in this case, for example, you will come up with, for let's say 64 antennas, you will come up with only 4 or 3 or 2 RF chains maybe, right? Depending on what your algorithm returns. So you will end up with something like this. So again, I'm not going into technical details. If you're a student, researcher, or someone who wants to pursue these kind of ideas, please have a chat with me. So you have, let's say, an energy efficiency equation. You have rate over power. It's dependent on your beamformers. And, the dimensions of these beamformers are deciding how many RF chains you are going to use, how many quantization units, and so on. So you want to optimize this depending on several constraints. So you have sensing constraints because you're using a dual function signal, sensing and communication signal. You plot in your energy efficiency, right? So this is an optimized energy efficiency because the algorithm that you're trying to implement here is going to give you that particular solution. And one trade-off is there, is that when I'm trying to see the performance of my communication metric, so for example, energy efficiency is a communication metric, as soon as I start introducing sensing, the performance starts degrading, the communication performance. So the idea is that you have to make a choice that whether I need my equipment or my device to work as a complete sensor or just as a communication device, right? So there will always be trade-offs. So as soon as you have very good performance, let's say, for communication, so green guy is just communication, you don't have any sensing at all. As soon as you start introducing sensing, the performance starts degrading. But for the sensing side, it's different. So let's say if I want to check beam pattern of my signal that is there, the dual function signal, you see that when I am giving this weighting factor, the low value means that there is dominance of sensing side. So the performance of sensing gets much more closely overlapped with the ideal case. So there is always a trade-off. You can have many other performance metrics. In this case, I picked up beam pattern. You can pick up probability of detection, false alarm probability, or PAPR values, or peak to average power ratio, or whatever you like, right? And we have done several papers around these ideas as well. And you can also make it spectrally efficient. There is one catch, so we have less time, so I will skip this, not going into too many details. But one thing I would like to highlight here is that when you're making it energy efficient and at the same time spectrally efficient as well, you can also introduce some sort of interference, right? So let's say your sensing guy will give some sort of interference, intra-operation interference to your communication guy, and communication guy will also give some interference to your sensing. So if you want to take that into account, you can do that and put this in your maximization problem, right? And you can solve using some fractional programming methods, or there are many sort of signal processing methods. I mean, if you're from information theory, it must be very easy for you to understand, is that how to make this approximated solutions and so on to make it from, let's say, fractional programming, sort of fractional numerator denominator to, let's say, difference-based optimization. You can do that. This is quite easy. And you also keep the trade-off factor as well, as I was mentioning in the previous slide, that your sensing and communication always are in trade-off. So you have to make a choice that whether you want communication performance better than the sensing or vice versa, right? And you can also do some hardware impairments. I mean, we have done another paper around hardware impairments when, which is more like a practical scenario. Theoretically, you talk many things, but this is more of a practical scenario. And you can come up with many sort of applications. So in IoT and robotics, so robotics, as you know, is a very niche area, right? And combining ISAC for robotics is also one of the key points many industry people are picking up now. So to use the sensing and communication together for robotics is also one of the emerging areas that we see. You can use it for many applications. You can have it for 3D localization, for example, where you require very high accuracy of your localization method, right? So sensing capabilities, adding sensing capabilities is very important that time, right? You want to achieve some sort of centimeter level sort of accuracy, right? Not centimeter wave. And you can come up with some simultaneous imaging, mapping, localization as well. So in indoor facilities, outdoor facilities, many other sort of applications. Smart healthcare, remote surgery as well is a very good application. Wearable sensors we used to have, now you can also put underneath the skin as well if you want to put some sensor. That is also possible. Someone in the morning was also talking about using body as the whole communication thing. You can do anything, but be careful. So you need to be aware of all these technologies. And many other things, gesture recognition, emotion recognition, fall detection, many other applications you can come up with. So ISAC, you see that 32 industry use cases, very initial ones, have been decided, but they can be advanced to many other sort of methods and approaches. And we have done a paper around this, so with our colleagues in Huawei, with Shuli and the team, we did the paper there where we discuss about all these use cases and so on. So please feel free to go through these. And one of our new works is also coming on to, sort of using ISAC for robotics in let's say, a couple of weeks, let's say. And we need to keep in mind that, okay, we talk about these fancy things, how many use cases and how many applications they have, but there are many challenges there are, not just technical, non-technical as well. Regulatory considerations out there, how to use spectrum, how to harmonize the spectrum, especially, let's say, when you're taking a direct access from satellite, for example, to do sensing and communication, both is a dual function signal. You can't be sensing everything, right? So this has to be regulated. You are having a driverless car, you want to check where is the next traffic signal, or where is the, some sort of infrastructure that I may need for my, a driverless car, for example. in that scenario as well, you can't be sensing everything. For example, you are in a confidential sort of area, you can't be sensing. So there has to be some regulation there. So that is one. Then security is a major concern. So again, when you want to sense, you need to be very careful that what are the things that are required to be sensed. Security, privacy is also one of the main challenges, very important challenges these are. And you have data handling as well, because you're joining multiple functions together. So how to process this data, how to design intelligent waveform, right? How to make it more efficient for this joint signal, how to use the channel, right? That is very important because you have your electromagnetics principles for communication. So I come from communication background. I know almost everything about communication. But when I want to bring sensing capabilities on board, I might be thinking twice, right? That how I can merge this sensing channel model, which is a bit tricky, right? And how to combine this with the communication channel model that is there. So that is also some point that we need to work on in these next couple of years. Then when we talk about making our signals more dynamic, we can talk about meta surfaces, right? So not just using multifunctionality, but we can make these approaches more dynamic as well. You can use some sort of large meta surfaces where you can actually reflect your signals, especially when you're going to millimeter wave or sub-terahertz bands. You can throw in your beam onto this large surface. It maybe look like a solar panel or something. It can be on top of roof of your buildings, or it can be on your flying platforms, or it can be on satellite or something. The idea is you throw in your beam that is there, and it reflects to the intended direction of your user, right? So it gives you some sort of additional dynamic method, dynamic approach to basically steer your signal where you actually want to steer it, right? So many variants there are. So I don't know if it looks like a small picture. I used to have the whole large slide for this. But you can use, these are mostly passive elements. You don't need to amplify it. But if you want to amplify, you can put a reflection type amplifier. It becomes active meta surface. You can make it hybrid. Some of these blocks, let's say you have a large screen like this. You have small blocks inside, right? Some of these unit cells can be active. Some of these can be passive, right? Or you can play around with your OFDM principles. You can come out with meta prism. Or if you are scared about standards, how to freeze these standards for meta surfaces, you can use smart skin. You don't need to reconfigure at all. Just program the thing and put it there in your network. Or you can come up with stacked meta surfaces. Becoming very important now is the stacked intelligent meta surfaces. Like you have the layers of your meta surfaces, basically to increase the degrees of freedom, right? I want to use something like messy MIMO. Or it has analogy actually to deep neural network, is that how to maximize the joint spectral efficiency by using different layers of meta surfaces. So it becomes very important. We have done several papers around these ideas. Another book is coming on this as well about combining information theory, signal processing, electromagnetic wave theory, and so on. So you will see, I think, in the next few months or sooner or later it will be out, the book. And you can also combine with index modulation. Today I was talking to someone who was looking for nice modulation frameworks and so on. So you can also combine, you can play around with different diversities, antenna diversity, frequency diversity, and so on, or polarization diversity as well, to able to avoid the need to do the detection at the receivers, because you're wasting a lot of energy or cost sometimes to detect these signals, like from which user this signal was, right, in our conventional approaches. You can avoid that by already embedding that information at the transmitter, so you don't really require some extra successive interference cancellation units. So you can combine these with risk transmission. So the idea is, again, you're not using the whole surface, you are using just few blocks of this, and you can embed some information depending on what diversity you're using, spectral, or your antenna diversity, or your polarization diversity. There could be many things there, right? Again, we have done several papers around this, not going into details. You can follow these. And you can come up with many amalgamations as well. So again, all these meta surfaces that I talked about, they can be deployed on the ground network, on your terrestrial network, also can be with your non-terrestrial entities. You can mount your meta surfaces on your flying platforms, or even on your satellites. So let's say one satellite is on the one side of the equator, another satellite is on the other side of the equator. No direct line of sight, right? It's too difficult. So the idea is that you can use all these satellites as buffers. You can mount all the meta surfaces, just a sort of ideal scenario. You will start reflecting your signal from one satellite to the other until you reach the other side of the equator, right? So The idea is that you can use these meta surfaces, not even in smaller indoor applications, can also go larger, right? Depending on how much you can afford. And these are very, cheaper elements, no need to use, so much of expensive elements when you use meta surfaces, let's say. And you can combine joint sensing communication as well with these meta surfaces and so on. We have done several papers and stuff. But also remember that the industry guys or the standards guys, there are many of you here, would be not willing to try meta surfaces in your because you have repeaters, relayers, and so on. But believe me, when we are talking about the holographic MIMO or holographic meta surfaces, so we are going to see that maybe these can be picked up into next sort of standard. So it's not right there. Right now we have non-controlled repeaters like NCRs and relayers and so on, many things. We don't have meta surfaces included in our standard. So it is a bit debatable sort of topic, but the idea is that if you keep coming up with some advancements into these dynamic approaches, you can come up with better solutions. You can combine with ISAC. Again, you can use a dual function signal here and pick some of these unit cells. No need to pick the whole surface. Need to be mindful of the trade-off as well, as I was saying earlier. And you can combine your non-terrestrial networks with your meta surfaces, or the other way around, meta surfaces with non-terrestrial networks, mount them on the drones, mount them on the satellites, or they can be stationary on your ground as well, wherever you need this reflection to happen, wherever you need to reach larger distances, right? For example, if I want to get a signal, direct access from my satellite to my smartphone, I might be really far away. There might be a very high latency problem as well. In those scenarios, if you plug in some meta surfaces somewhere, let's say first on the building, then it goes to you, you get rid of it to some extent because you are basically buffering the signal to be forwarded further. Again, many papers, so I like to sort of publicize our output, so given the link. So if you have these slides, please feel free to go through these. And you can also integrate into NTN, not just meta surfaces, but machine learning AI methods as well, right? You might have seen these things several times, but here in a couple of our papers, we try to use intelligent resource allocation. We try to use some sort of gradient-based method, depending on deep reinforcement learning, how to actively select the computing and communication resources in a 3-tier network architecture. So let's say if you have satellites, you're talking about mega constellation NTNs, mega constellation satellites, your LEOs connected with GEOs, MEOs, and so on. In such a scenario, you can put all these on edge plane. So you have your all these inter-satellite links on edge planes, and whatever information you may not require right away, computationally inefficient information, you store it in the cloud, right? When you need it, you will have it. And you're also sort of communicating with your ground network. Very important point is that I'm talking about the integration of non-terrestrial and terrestrial entities. I'm not asking to replace the terrestrial, the ground network. So never get this confusion. Basically, this is to integrate this. So in such a tier network model, like you see here, like here, right, with the satellite edge plane and cloud plane and also your ground plane, and you can plug in some actor-critic network, or you can come up with some other advanced deep reinforcement learning methods or machine learning methods to come up with low complexity, low latency, and high cost efficiency as well, right? So we show some results around these areas, and we have done several papers around these topic as well. So the idea is that you can use ISAC, you can use meta surfaces, you can use machine learning methods as well, and combine with NTN. Because NTN is a very important technology because it gives you many good use cases, greater good applications, right? So in public safety, so in Turkey as well, you had, unfortunately, a disaster some time ago, right? So in such a scenario, all your infrastructure is broken, right? Basically, you have the base stations that were giving access to your mobile users or your other sort of devices, equipments, that is all gone because of the disaster. Such a scenario, you send in your drones. You send like a swarm of UAVs. They extract information, pass it back to another control center unit that is actually operating, right? That is actually functioning. And in such a scenario, you can even perhaps not just UAVs, you can take this access from your satellites as well to basically operate that area, to manage that area, post-disaster management, mission-critical applications, right? So it becomes very important. Again, we talk about this, combining this with AI, machine learning, unsupervised or even supervised machine learning, and many other topics we have done around this idea as well. Some of these are listed here. Is basically the idea is to combine NTN with multiple technologies, right? This is one of my most favorite slides. Is basically gives you a complete picture. So whatever technologies I have talked about, so ISAC, your drones, your satellites, your putting in some AI models, some intelligent resource allocation, edge computing, cloud computing models, and also trying to, use meta surfaces as well to reach larger distances. This is a complete picture, whatever I've talked about. So if you have, let's say, a mission critical application to serve or a disaster management to do, public safety application, you can use all these technologies together. No need to be shy. There are many complexity issues here we need to think of, security, privacy, and stuff, but keeping in mind that this can be also doable when you combine multiple things. You can mount your meta surfaces on swarm of these UAVs, you can put them on satellites or on the stationary objects like this one on the roof of a building, let's say. You can have even on your vehicles, roof of a car, you can put it on, and you can serve this sort of disaster affected area, right? And this is, I think, one of my last slides. So basically, you can also advance this even further. So we have done a recent paper, it's published in JSAC very recently, is that you are combining all these things. Can I add even more technologies? You can add quantum as well into this. So it looks a very complex scenario, but please try to go through this paper. The idea to pitch in here is that you can use it for different applications, not just commercial applications, military applications as well. So we had some people from defense at the conference, so you might be very much interested into these sort of ideas as well. How can you use drones and your satellites and so on, using meta surfaces, using this joint signaling of your core design of sensing communication, and come up with very cost-efficient approaches. Because remember, our 5G infrastructure is not that cost-efficient. There are works going on, but still we need to make it more cost-efficient as well. So there is the link to the paper. So many conclusions. Again, I will not read all of these. Future is bright, and keeping in mind that we have several challenges to think about. So I gave you this wide picture about using all these technologies together and multiple things together. The message is clear that 6G is not just communication, it's beyond communications, right? It's sensing, it's AI, it's localization, positioning, computing, everything combined, immersive, right? So it's not just communication, it's beyond that. Keeping in mind that we have several challenges to face. So different countries have their different challenges. So if you are a service provider, you need to think how to overcome these challenges. If you are industry developing solutions, you need to think about how to get rid of these challenges. As academics, we can do approximations, so we are a bit more flexible, right? But if you want to plug in these methods, these algorithms into your devices, you need to be mindful about these as well. And if you are really interested, last slide, so not to take much of your time, so we do a lot of podcasts and a lot of videos as well, a lot of lectures. I don't know if this one is being recorded, but you can find us on YouTube, and hopefully you will learn a thing or two, because we do a lot. Maybe with Hüseyin we'll do another podcast in London or somewhere. But the idea is that you see that we do many of these videos as well if you're interested. Thank you so much.
I don't know about you, but I need a break. There was a professor, actually, young professor, right after the lunch. We were just talking. She said that, Dr. Arslan, I feel so overwhelmed. In Turkish, there is a saying like, a fish out of water, okay? So I feel like I'm a fish out of water, okay? So much to learn, so much to grasp. So I'm so motivated. Now when I go back home, I'm going to be working day and night, publishing. I feel the same, Aryan.
Shouldn't publish too much. Yeah.
I feel the same. I feel like I'm out of the fish out of the water.
Struggling.
Anyway, so tomorrow morning I'm going to start working harder. How many papers that you published in 2024? Q1. All of them
idea.
are Q1.
No idea.
Yeah, I think at least 40 I count.
Thanks, David.
Well, really great work. I mean, like, the young guys. I mean, in Valencia, he told me, like, Dr. Arslan, you are my role model. No, you are my role model.
Yeah, thank you.
I mean, yeah, great work. So, I mean, I know, like you all, I need a break, but you all need a break. But unfortunately, we have an excellent panel now, okay? Something that I think you all are looking forward to it. Something that's very much related to what happened last week. And something that we have to learn a lot, and we have to, also take the necessary precaution so that it doesn't happen to us. And something that, one example that we have seen last week, but maybe there are many that we don't even know. So it's very important that, we take our time, okay, for this panel, because if I give a break, the panel is not going to be as much because, we have also other speakers. So I would like to thank Aryan again, give his gift. Again, President, if you can
Thank
give
you.
him the gift. Actually, I want to be in the picture if it's okay, because he is the superstar. He's going to be the future star. So maybe I may not have the opportunity to have a picture with him in the future. So it's my time again.
No, we will have.
We will?
We'll be alive.
Okay. We'll collaborate as well, right?
Definitely, yes.
All right. Can I hold my hand as well?
Yes. we can.
Oops. Okay, all right. So, Ulaklara mı ödül vereceğiz? Panelden sonra. Biraz daha bekleyin. Panelden sonra. Ulakçı arkadaşlarımızı biraz daha bekleyeceğiz. Who was the moderator for? Enis Bey. Buyurun. Enis Bey is the moderator. So I'm going to sit here and then you introduce the panel and the panel.
Thank you. Thank you, Mr. Rector.
Okay, dear guest, we will continue the session, the seventh panel, Communication Network and the Device Security. I will now leave the microphone to our panel moderator, Enis Müşteba Memiş. And our panelists, Dr. Yasin Cengiz Çelik, Yalçın Aydın, Dr. İsmail Güneş, Dr. Göksel UÇTU, Dr. Emin İslam TATLI, and Mahmut KÜÇÜK.
Sıralamayı ben söyleyeyim size. Yasin Bey önce. Yasin Bey, Yalçın Bey. Sonrasında İsmail Bey, Göksel Bey, Emin Bey, Mahmut.
How many panels we have? 2, 4, 6. Wow. So much to talk about, right?
Mr. Rector, with your permission. Dear distinguished guests, Rector of Medipol University, panelists and valuable participants from communication sector, academia, SSB and all our government entities, representatives, professionals from various sectors, students, ladies and gentlemen. Welcome to our panel titled Communication Network and Device Security at the 6G conference today. I greet you with my all respect. The subject of today's panel is the security of communication devices and the networks which have become an inseparable part of our lives, academic researches, business world, and daily routines of our last 50 years. We observe that the end-to-end risks related to access to and device security have not diminished globally. Rather, they have increasingly risen. From cryptographic communication to data security, the need for domestic and national solutions has become even more critical at every point of the supply chain. At this juncture, it's evident that the collaboration of solution providers in offering integrated solutions holds significant value. Turkey has emerged as one of the leading countries in this field, particularly its cybersecurity clusters and leading firms in the sector. Especially in recent times, there has been a significant increase in efforts by individuals, crime and terrorist groups, and state actors to breach these security issues, as well as initiatives aimed at exploiting these breaches. In this panel, we will hear from the professionals and academics working at the both professional and operational levels regarding to these issues. After owing this short entrance, I would like to skip to introducing our valuable participants which are attending to our panel. Mr. Yasin Cengiz Çelik, Cell Development Manager of ASPİLSAN. Mr. Yalçın Aydın, Hardware Design Director of AVŞAR. Dr. İsmail Güneş, Cybersecurity Institute Director from TÜBİTAK BİLGEM. Dr. Göksel UÇTU, Cybersecurity Services Group Manager from HAVELSAN. Dr. Emin TATLI, Cybersecurity Director of Turkcell. Mr. Mahmut KÜÇÜK, Cybersecurity Director from Türk Telekom. After this short entrance, I would like to give small resumes of each panelist at the beginning of their questions. Dr. Yasin Çelik, the Cell Development Manager of ASPİLSAN. Mr. Çelik graduated from Boğaziçi University Chemical Engineering Department in 2004. He took his master's and PhD degrees in 2009 and 2015 respectively from Kloster University of Technology in Germany at the Department of Chemical Engineering. In 2008, he awarded the first place with the team of Kloster University of Technology at the ChemCar competition with a magnesium air battery model car in Germany. He had an experience on super film packaging films and working as cell development manager in ASPİLSAN since 2018. Dr. Çelik, would you please tell us what are the safety systems in lithium-ion cells? What can trigger the explosions in them? This is the most excited questions, I guess.
Thank you so much, first of all, for your invitation and for your question. Let me begin first why we are talking about so much on lithium-ion cells. Lithium-ion cells are becoming more and more hot topics because of their some major advantages. For example, they offer us high energy density, longer lifetime, and also higher charge capability. So if you want to use smartphone with longer lifetime or electric vehicle with longer range, we need lithium-ion batteries. Why do they have high, if they have high energy density, it brings also some other problems. For example, due to explosion, it also emits too much energy, and it damages the environment much more than in comparison to other batteries. So how can we make these high energetic lithium-ion cells safer? As ASPİLSAN is the first 1865 lithium-ion cylindrical cell producer in Europe, we are aware of that the safety of the lithium-ion cells start from the raw material level. To produce 1865 lithium-ion cylindrical cell, we are bringing around 20 different components each other. And some of these components have also some sub-components. For example, electrolytes may have more than 5 or 6 chemicals. NMC or LFP, maybe you are already familiar with them, contains of nickel, mangan, cobalt, lithium, and also some additives, much more chemicals. So first of all, you need to work with very reliable raw material suppliers, and also you need very educated and also experienced incoming quality department, so that you can be sure that every time you are using the same raw material, okay, so that it ensures your cell performance, also cell safety. But can you 100% trust on your reliable suppliers? Especially recently, there are many news about the infiltration to supply chain. So maybe it is very critical not only trusting on your raw material suppliers, but you need also very well incoming quality testing department to test all these around 20 cell components, because any change, any defects of these 20 components may cause a bad cell performance or maybe the bad safety. Actually, if I bring the very easy level, making a lithium-ion cell is similar to making a cake. To making a cake, you need some ingredients, okay, and to mix them. Similar also making the lithium-ion cell, because in lithium-ion cell we are mixing the different powders separately for positive and negative sides, okay, and coating them, and drying them. And think about that. If you change any ingredients for during the making the cake, what will be the result? You perceive the result as a bad taste. And similar thing appears in cell, bad performance or the safety. So first of all, you don't need to change your raw material and to be sure of the quality of your material. And second, the process. Think about that. When you, even the sequence of the mixing the ingredients for making cake, it changed maybe the structure or the taste of the cake. Or even some making cake expert says, first of all, take out your eggs out of the fridge and bring the temperature to room temperature so that you can make the best cake. Similar thing also happened at the lithium-ion cell production. You have to prepare that your mixing powder slurry at the same temperature, at the same viscosity, and bring them on the electrodes with the same thickness. What happens if I don't coat them with the homogeneous thickness? Lithium-ion cells also known as rock chair system. It means lithium ions travels between minus and positive electrodes, and they are hosted in them. During charge, they are hosted in the minus side, and during discharge in the positive side. So if you don't have the homogeneous electrodes, I mean the thickness, what will happen? They cannot move smoothly, okay? And when they cannot move smoothly, they will cluster. They will cluster, and they will cluster, that lithium ions turn into lithium metal. Why it is it's so important for us? Because when there is a formation of lithium metal, okay, it can penetrate the separator. Separator is a system, mostly polymeric system that separates the anode and cathode. And when the lithium, that cluster lithium metal penetrate the separator, it touches the other electrodes and causes the short circuit and ends up with the explosion. So to prevent it, you need also very good production control system and also many sensors to be sure that you are producing very homogeneous electrodes, okay, and also very mixed powders. And what can we, is there any safety system to prevent this lithium dendrite penetrate to other side? Maybe increasing the thickness of the separator, or for example, in our production in ASPİLSAN, we are using ceramic coated ceramic, okay? So it increases the puncture strength of the separator so that lithium dendrite cannot easily penetrate the separator and cause the short circuit. And especially that short circuit happens also at very low temperature and during charging. So if it is not necessary, don't charge your lithium-ion cell at very low temperature, mostly minus less than 0 temperature. How can we also prevent any defects here? By making a very good electrode design. It means you should also adjust the amount of that powders in your minus and cathode, minus and plus electrodes, so that lithium ions can always move smoothly, okay, can and easily find their host either on the minus or the positive side. And why may it also cause a big problem? In 2016, one of the biggest smartphone producer recalled many millions of their smartphones. Why? Because there were many news, they were exploding, okay? Even that smartphones in 2016 were banned in the flights because of the danger. And after some years, that company explained that they made a mistake with the electrode design. It means the shape of the electrodes, it's also very critical. It can easily cause lithium-ion explosion. And another important point that your cell production atmosphere must be very clean and very low level of the humidity should that have. Because humidity and contamination can easily also cause the defects in your cell. It not only causes the decrease of your cell performance, also danger your cell safety. So during the production, we are producing all that electrodes at very low level of the humidity, and also all the particles are being detected with the sensors, okay? When it is above one limit, then we have to stop the production. I am telling that these are about the internal reasons for the lithium-ion explosion, and after that I will also talk about the external short circuit. And this is finished. No, not yet. After that, electrodes are prepared. Okay, minus and positive electrodes we produced, and after that they should be rolled up. Okay, to bring a cylindrical shape. And during that rolling up, we are bringing minus electrode separator, and after that positive electrode and rolling them up. And anything may happen. In 2019, one of the biggest cell producer was sued to pay around $2 billion because of the defects of their batteries, because their batteries exploded in electric vehicles. And after some year, it was also reported on some news. It happened because of that separated folding, okay? Think about it. You are rolling up the electrodes, okay, with the separator. It looks like a very easy process. But if anything goes wrong, okay, that you're separated, folded, what will happen? It may change your alignment of your electrodes, okay? So maybe they are not face-to-face each other now. So lithium ions cannot move smoothly, or that separator folded, okay, and also prevents that lithium transport, okay? That may also cause, again, lithium dendrite for lithium metallic formation and cause the short circuit and explodes. And many of the cars at that time also exploded, and that company had to pay $2 billion compensation. And after that step, we produced the cell at very controlled atmosphere. Many sensors checked our system. Is it finished? Not yet. We have to also check the capacity and internal resistance of our cells, because in some system you don't need not only one cell, but you need to bring many of them together to make a battery pack. So they should have as identical as possible. So we are checking their capacity, voltage, internal resistance. And after that, not finished yet, to make all our cell much safer, we are making some quality control tests. For example, we are crashing the tests, crashing our cells, okay? Dropping them, vibrating them, horizontally, vertically, heating them, okay? Overcharging them. I mean, for example, many lithium-ion cells should be charged up to 4.2 volt, okay? But we are charging them more. We are exceeding the limit, and see what happens. If they don't explode, okay, then we say our cells are safe. And many of the reliable companies, okay, delivering such cell after this test. So it's not so easy. I mean, after following all these orders, process controls, okay, to bring a cell to explosion. Because if you work with very good quality of raw material, you follow all your process control plan, and sampling for the quality test after finishing the cell production, they are much more reliable then. It is finished, my last point. Not yet. We are still not sure if something goes wrong, okay, we should put some safety system to our cell. What can we put? We are producing cylindrical cell, okay, and this cylindrical cell has a lid, which also called top cap, okay? In the top cap is the positive pole of our cells. And in this system, there are at least two mechanical safety measurements. First of all, if something goes wrong in your cell, okay, first one component, which is called CID, current interrupt device, is triggered. For example, any site reaction, or when the temperature outside increases, the pressure also increases inside, okay? It triggers that system, that current interrupt device, okay? It moves, it works like this. The top cap is, the lid is like this. There are two plates, okay, contacted each other. When the pressure increases, okay, one separate from others, okay? So it cannot conduct electricity anymore. So you can neither charge nor discharge it, okay, and trigger the site reaction more. But if it is still unstoppable, okay, there is another safety system, which is called gas ventil. When the pressure exceeds some limit again, okay, gas ventil opened, okay, and it transfers the high level of the pressure, control it out, so it will not explode. This is one of our safety system.
Thank you, Dr. Çelik, for the explanation. Now we are speaking to Mr. Yalçın Aydın, who is the hardware design director of ASPİLSAN. I would like to give you short resumes also. He was graduated from Middle East Technical University in 1996 and took his master's degree in 1998 at the same university and same department. He has been working at ASPİLSAN since 1996. He is an expert in RF and microwave design. He has got 2 children. He is working as Director of Electronics Hardware Design Directorate at ASPİLSAN. Mr. Yalçın, would you please tell us what kind of precautions do you have to take into account in your hardware design processes? Thank you.
Thank you very much. First of all, I would like to thank Hüseyin, Aslan, Hocam and audience for this valuable workshop. I am going to talk about our hardware design precautions in ASPİLSAN and about our infrastructure, design, production, verification, and environmental test capabilities. After that, I am going to give some information about our cyber security precautions. And at the end, since this is a hot topic, I would like to give some brief information about our lithium-ion battery pack smart protections. About our infrastructure, we have our own procurement chain management capability of electronics and mechanical components. Incoming inspection departments check the quality of all procured components first. We have our own PCB production capability, and we can produce all electronics boards by using our own assembly and electromechanical assembly lines. Most of production steps, including PCB typesetting, reflow, assembly integration, and tests are done in ASPİLSAN campuses, which are in control zones. About design phase precautions, all design phases are carried according to reference design standards. All circuits are analyzed firstly, and all needed analysis, for example, part stress, the rating, worst case, safety, reliability analysis are done prior to prototyping stage. According to analysis results, needed precautions are taken into account. I would like to give some short hints about PCB for PCB designers. For example, conductor optimization between lanes is important. Symmetric routing should be preferred. PCB layout design should be compatible with IPC 2221A to prevent any electric arc. Trace and plane clearance are determined according to operating voltage range to avoid any arc. About EMI/EMC precautions, electromagnetic shielding is essential for protecting electronic devices from unwanted interference caused by external electromagnetic fields or reducing the emission of electromagnetic radiation from the device itself. Our communication systems are qualified according to some military standards, including environment and EMI/EMC and others, like military standard 810 and military standard 461. RS-103 radiated susceptibility and some conducted susceptibility tests are important in terms of safety of device for any attack against the equipment. All EMC test results are reported and required precautions are taken. After all these tests, equipment is secure against any electromagnetic environment, including ESD and lightning in some conditions. Required grounding and shielding are done. Built-in test and alarms. All of our communications equipments have built-in test features. If any critical temperature, voltage, current, or RF level are observed, required precaution immediately is taken by device hardware without needing any high-level software intervention. This is a very important case. These alarms and built-in tests are important in terms of safety of device. Failure propagation are prevented by means of these abrupt control scenarios. Required parameters are observed by unlock circuits, and unlock loops can be used usually beside digital controls. In our production and test phases, after design phase, all designs are verified by qualification test department. All design, production, and test phases are carried out in ASPİLSAN security zones, which is certified by related organizations. All components and materials are controlled and accepted by input quality control. Any inappropriate component or material rejected. About environmental test capabilities, besides EMC testing, all environmental tests also are performed in ASPİLSAN facilities. We can design equipment and system for different platforms from ground, army, naval, airborne to space. This experience coming from the heritage enables us to develop reliable, secure, high performance and robust systems. All product families are qualified according to related environmental standard. Military standard 810 and US standards are most used ones. All environmental tests proves the device endurance and performance in harsh and tough environments. Our in-house designed waveforms are very robust against any jamming and spoofing. All electromagnetic RF environment are taken into account, and RF design are done thinking all interferers and jammers. High dynamic range, RF filtering, coding, spreading, signal processing are key factors to communicate safely in a jammed area. All electronic warfare precautions can be done by ASPİLSAN. About cybersecurity, in addition to hardware design, production and qualification precautions taken for safety and security of radio, cybersecurity precautions are also taken at all layers of communication as Tempest, CompSec, Transec, and NetSec. All software development, including waveform design, signal processing, control, and interface software are developed by ASPİLSAN engineers in an isolated and secure zone. ASPİLSAN communication systems can serve as isolated networks. All communication infrastructure, including base stations, mobile and hand terminals, can be supplied by ASPİLSAN as a turnkey solution. Our isolated networks are secure against cyber attacks. All cryptographic development are carried in ASPİLSAN related security zones. All precautions, including black and red separation, are taken by hardware and software design. Communication between our radios is encrypted and authentication mechanisms are used between devices, making it very difficult for unauthorized persons to access devices and send commands. Strong national encryption, decryption algorithms and key lengths used in our communication devices that are very difficult to break. The keys are securely created, distributed, and stored. Private keys and sensitive data are stored in a secure environment which is called crypto subsystem separate from the main operating system. ASPİLSAN communication devices cannot be programmed by any unauthorized person since signature verification and harsh control algorithms are used together by preventing data from being modified. Our Tempest and Temper precautions. Our devices have Tempest compliance STIP 27 NATO standard that handle classified and unclassified information to prevent compromising emanations from crossing between them. Countermeasures are taken such as shielding, filtering, and grounding of equipment, as well as the use of secure enclosures. Our devices are internally aware of external tamper attacks. Abilities range from tamper detection to erasing sensitive data. What this means, even if an external intervention applied to device, hard or soft, even if there is no power supply, our device can erase everything, every sensitive data by itself without any supply. CompSec, Transec, and NetSec, we have anti-tamper precautions approved by CompSec to prevent physical attacks to our devices. These measures are very strong and designed originally by ASPİLSAN. Cryptographic algorithms that are used for data encryption, authentication, and digital signatures are implemented directly in specially designed hardware. Red and black separation takes place to create isolation between security domains. This can be achieved through dedicated hardware components, secure boot mechanisms, side channel attack immunity, and stroke isolation. Our waveforms has capable of fast frequency swapping using strong national cryptographic algorithms as a transsec feature. NetSec measures are the security controls we add to our devices to protect confidentiality, integrity, and availability. NetSec takes effort to keep attackers out of our network. This shows our black and red separation in a device. And I just put 2 slides for the events happened last week in Lebanon. We are collaborating with ASPİLSAN, producing lithium battery packs smart protection. The main reasons for the presence of protection circuits in lithium-ion batteries are safety and preserving battery life. Due to their high energy density and sensitive chemical structure, lithium-ion batteries can be dangerous if not properly managed. My colleague examined and explained very briefly. Protection circuits help prevent various risks to ensure the battery operates safely and efficiently. For lithium battery pack smart protection, one can pay attention to overcharge protection, over discharge protection, over temperature protection, and over current protection. As a summary, I could say ASPİLSAN has been designing and producing communication systems for nearly 50 years. For a secure and safe equipment or system, ASPİLSAN has suitable processes and experiences start from design phase to production and qualification phases. Hardware designs are done according to worst condition and scenarios. Production and tests are carried out in secure and controlled zones. In-house waveform design capability, precautions are taken against contested RF environments. Software is done taking into account cyber attacks. At the end, this is my own opinion, products designed and produced outside of our country should be examined. We couldn't know what they put inside the device. Maybe everything like designed and produced outside of our country, maybe we can take their examine under X-ray. If there's any abnormal thing inside the structure, maybe we can open and examine by expert people inside the devices. Thank you.
Thank you, Mr. Aydın, for this presentation. Now we are coming to TÜBİTAK BİLGEM's representative, Dr. İsmail Güneş, who is the Cybersecurity Institute Director. Dr. Güneş has been serving as the Director of TÜBİTAK BİLGEM Cybersecurity Institute since 2022. İsmail Güneş obtained his undergraduate degree in computer engineering from Istanbul Technical University in 2003. He then completed his master's degree in computer engineering at Boğaziçi University and completed his thesis in the field of machine learning at Istanbul Technical University and received his PhD. İsmail Güneş has been working at TÜBİTAK BİLGEM OEKE since 2003 in the field of information security. He has served in various roles, including team leader, project manager, department manager. Additionally, since 2020, he has been fulfilling the role of Deputy Director of TÜBİTAK BİLGEM OEKE, responsible of digital assets technologies. Here is my question, Dr. Güneş. What are the biggest threats to communication security, and how can organizations be prepared for these threats?
Thank you. From my point of view, the biggest threats, of course, cyber attacks. As you all know, critical systems and devices have recently been targeted to some major cyber attacks. So I see the biggest threat, cyber attacks as the biggest threats. I want to talk about some cyber attacks targeting the communication systems first. The most prevalent cyber attack may be the man-in-the-middle attacks targeting the communication systems, and attackers usually secretly eavesdrops, steals, or modifies, manipulates a message between two parties during communication. It is very prevalent in communication, very prevalent attack, I guess. Besides, distributed denial of service is another large-scale attack targeting the communication security. In this type of attack, attacker usually uses a huge amount of compromised servers, computers, or IoT devices to make a massive amount of requests to a target server so that the server is unable to respond. It's a common attack in communication sector. Also, another attack might be phishing or social engineering, also threatening the communication sector like other sectors. In this type of attack, usually employees of an organization is convinced to share credentials to the communication platform. And the last attack I want to talk about is supply chain attacks, which is mentioned before. And this type of attack, as we have seen in a Lebanon attack, supply chain attack is usually attackers prefer to target third-party suppliers, components, softwares or hardwares, rather than targeting directly to the organization, because usually it is easier to reach or put a vulnerability into the systems than directly targeting the organization, because these components are obtained from external sources, and it is easier. In addition to these cyber attacks, another security threat is data encryption breaches. If you use a weak encryption protocol, usually attacker can decrypt the communication and gain access to your sensitive critical data. It's also another security risk. Besides, usage of insecure softwares or applications are another risk, because, for instance, if you use an insecure messaging application or if you use insecure cloud service, this can threaten your communication security as well. Besides, let me check. In addition to insecure usage, internal threats are another risks. Because your employee or business partner may cause a security vulnerability in your communication system with malicious activity or only just because of careless behavior. So this is also another risk to the system. This is an internal threat, and it is to be taken care as well. Organizations can take measures to prevent these risks. What should be done? Firstly, strong and up-to-date security and encryption algorithms should be used. For example, for asymmetric encryption, RSA or LT curve algorithms should be used with longer key lengths. And security protocols such as secure VPN for remote access or transport layer security should be preferred. And encryption should be mandatory for all transmission processes. And this is the first thing to be put in the list. And second, multi-factor authentication is also critical. Organizations should access to communication systems using multi-factor authentication, and the second authentication should be biometric, like fingerprint or iris, or certificate-based factor, if it is possible. This is also critical. And third, I strongly recommend to run regular penetration tests and monitoring of the network traffic for anomalies, because a qualified penetration test team can easily report security vulnerabilities of your communication system along with the measures and countermeasures. So this is also important in communication security. And I want to mention about internal and managing of internal and external threats. Organizations should reduce the internal threats by carefully managing the permissions of the employees, and also reduce the external threats by utilizing the defense tools such as IDS, IPS, or firewall systems, firewall tools, to reduce the external systems. And besides, organizations should regularly give security trainings to their employees, because they should ensure that they remain vigilant against social engineering attacks by these trainings. And lastly, organizations should continuously update their softwares or systems and regularly patch their vulnerabilities to avoid these cyber attacks, I can say. If these measures are taken, most of the cyber attacks can be avoided by the organizations. In TÜBİTAK BİLGEM, we have some solutions for communication security. Briefly, I want to mention about these solutions. One of them is high interaction honeypot system. Maybe you might know. By this product, we can get the attacker into a trap system, which is a simulation of real system, and we can analyze the behavior of the attacker using this product. Or we have a secure VPN system to ensure the security of the remote work. And most importantly, maybe, we have a network-based hardware security module. This module stores or products, generates, stores and manages the encryption keys. These encryption keys are used for encryption or signing the operations or data. And I think HSMs are crucial for the communication security and should be used, of course. And lastly, we have some IP security products to ensure the security of data, voice, and video transmission. Thank you.
Thank you, Dr. Güneş, for the cybersecurity issues. I'm coming to now Dr. Göksel UÇTU, who is Cybersecurity Service Group Manager of HAVELSAN. Dr. UÇTU graduated from TOP University, Electrical and Electronics Engineering Department with full scholarship in 2011. He completed his master's in Electrical and Electronics Engineering at Middle East Technical University with the support of TÜBİTAK Scientist Support Scholarship in 2014. Excuse me. He completed his PhD in Information Security Engineering at Gazi University in 2023. He worked as a research assistant at Gazi University for nearly 4 years and participated in R&D projects. He worked as a researcher and institute committee member at TÜBİTAK BİLGEM Cybersecurity Institute, as an expert system security engineer at ASPİLSAN, and as a cybersecurity test and analysis team leader at HAVELSAN. He's currently working at HAVELSAN as Cybersecurity Services Group Leader. Dr. UÇTU, please give us what security threats are today's communication networks becoming more vulnerable to, given the increasing number of connections and data volumes? And what are the most effective defense strategies against these threats? Thank you.
Thanks, Professor. I will try to mention about the media part of this question, because Dr. Güneş also mentioned about the threats, and I want to consider the question as in the latest recent news, as we all know from the media. So I will first start with targeted attacks, as Dr. Güneş said. The targeted attacks are supported usually by nations or states, and also some focused cyber criminal groups. And their target are usually nations or companies or specific products or some specific protocols sometimes. And lately we saw some common targeted attacks, and Israel and Lebanon war saw us a specific example of this. But in this section I want to mention about Israel and Palestine war actually. because in this war we saw that targeted groups from Israel, as I remember, the We Read Evil cyber terrorist group, I think, terrorist group, has lots of attempts in this field. They try to spread this information into the media when a bureaucratic leader or a politician gives a declaration to the media, especially. And we saw a specific example when our president, Mr. Recep Tayyip Erdogan, declared that we are at the side of Palestine. They immediately published some photographs, some proofs in their Twitter X accounts that they have some critical information about our defense industry, etc. We also, of course, investigated all these pseudo proofs, and we saw that this is disinformation spread to the media. And of course, to prevent these targeted attacks, there are lots of technical countermeasures in both academic world and also practical side. But I want to consider this issue in two main headings. One is global scale and the other is nation scale, because when we consider targeted attacks or any other cyber security attacks, we are alone as nations. In the global scale, of course, we implement the best practices at each layer of networks, OC layers, etc. But we usually miss the business logic of the network, in especially academic area. In my PhD thesis, I also considered in one chapter, as an example, I considered multicast network security, an old technology. But when I'm investigating, I saw that the attacks are usually classified as man-in-the-middle attacks, social engineering attacks, malware attacks, etc. But in each particular network, in each particular design, you have to consider the specific protocol-based attack types. But I saw that there is not a specific solution for protocols. And then I investigated the RFCs of some specific protocols in multicast network, and I saw that there are two clear attack types can be implemented in multicast networks. So I go a deep dive into this topic and saw that these attacks can also be implemented. I showed that in the some implementation works. And I think to prevent cyber attacks in global scale, in academic perspective, we must collaborate with some fundamental areas as cybersecurity researchers, because cybersecurity is not a standalone unique domain, it's a multidisciplinary domain. We are coming from network administrator, system administrator, or software development domains. There is not a pure cybersecurity professional, I think. So we must collaborate and give solutions to these fundamental protocols or business logic cases, I think. And the second one is the ransomware attacks, as maybe most of all here have heard of it. It's also a mediatic attack type, and it aims to encrypt and demand some money, ransom money, to decrypt the data of the organization of the company. And this attack type also arose in the last few years, and around the world it increased over 60%. And after these attacks become successful, of course, some of them are just remain as attempts. Approximately the 50% of the victims had to pay the money to the groups. These statistics are terrible, and we saw that we are not prepared for the prevent these types of attacks. And the third one is supply chain attacks, as Mr. GÜNEŞ mentioned. We know what is the supply chain attack, but I want to mention about the latest incident. As all we know, the Lebanon and Israel case. In that case, when we look at the background of the attack, Israel Mossad agents, according to the Reuters agency, of course, I didn't individually have the chance to investigate the pagers by myself, but according to the research on this topic, we saw that Israel Mossad agents are intercepted the supply chain of Hezbollah Lebanon and implemented some kind of exposures in the pagers. And they sent a specific payload to the pagers that will cause the explosion. We saw in this case the supply chain security is a critical issue, especially in our or worldwide. In the defense industry, it's the heart of security countermeasures, security threats in defense industry. In the early 90s, cyber attacks are considered as basic defacements of websites or basic denial of distribution, distributed denial of service attacks, and served these attacks into the media. So people and companies and maybe governments thought that these attacks are nothing. This is nothing if our website is defaced or we have a short outage in our website. But at the background, all professionals here knows that the fact is devastating. These are just mediatic attacks, and we saw nowadays these attacks can cause deaths and thousands of wounded peoples. And also, I want to touch one of the latest attacks. It is not an attack, actually. It's not a pure attack. It's a cyber incident. I comment it like that. The Microsoft incident. We have to mention this. I think we faced this incident in a few months ago, as I remember correctly. In that case, we saw that an outage for a half day will cause the world to the chaos. The critical infrastructures, the global transportation sector, some financial sectors are highly affected with this outage. This was not a pure cyber attack, no cyber attack actually, but this showed that supply chain management failure can cause this type of outage and creates a huge chaos. In that case, a third-party supplier of a security company made a mistake while preparing a driver for Microsoft, and Microsoft got this driver, and the disaster began. And we saw if the software developer of that company was a cyber criminal or this was a targeted attack, we could easily consider this a cyber attack. This is just a word changes everything we saw in that attack. Thank you.
Thank you, Dr. Uçtu, for the explanation. Now it comes to Dr. Emin İslam TATLI, Cybersecurity Director of Turkcell. Dr. Emin İslam TATLI serves as the Director of Cybersecurity at Turkcell after completing his PhD in Mobile Application Security and Digital Privacy at the University of Mannheim in Germany. He worked as a cybersecurity expert and manager at companies SAP, IBM, Mercedes-Benz, Türk Telekom, and STM, respectively. Continuing his academic pursuits, Dr. TATLI has taught master's and PhD level courses in Istanbul Medipol University and Top ETÜ University. Dr. TATLI, could you please tell us, could you discuss the projects you have undertaken for mobile security at Turkcell? Thank you.
Enis Bey, thank you very much for the introduction. Actually, when I returned in 2013 from Germany, I started working at the University of Medipol. So today I feel myself at home, so it is an honor for me to be here. I would like to thank Hüseyin Hoca and the organization committee for their invitation. Considering the terrorist attack committed by Israel last week by exploding pagers and other communication devices, I believe that some certain facts have been proven once more. For example, we were always saying that cybersecurity is especially a national security, society security topic. It is not a technical issue. It has been once more proven. Therefore, security starts really from physical layer security, from the device security. If you are a country which has some critical infrastructures for securing, then you have to think about not just application layer. You have to start from the device security. So this is one topic. Another is, it has been mentioned many times, supply chain security. Supply chain security cases have been experienced in the last years several times. But at this time, by the supply chain security, some death causes, some casualties have happened. Therefore, if you look at from the mobile forensics perspective, they put some explosive material into the devices. Therefore, we have to consider supply chain security as an additional point for software vendors, for physical devices, as well also for service providers. It's a very challenging problem. The world actually suffers from this challenge as well, but in the near future, I will believe that we will talk about much more about supply chain security by considering these death cases actually. And we have realized that we have once more seen that development of local products, national products, is much more critical as we think. In Turkey, there is a Turkish cybersecurity cluster. There are more than 200 companies that are involved with this cluster, and we have to once more we have to give the priority to local products before using a foreign product. And lately, the last one, which I take as a lesson from this attack, is if you use a foreign product, you have to perform some deep, automated, continuous security assessment of these products. So these are the lessons which I take actually from this event. As a telecom operator, as a mobile telecom operator, of course, we are operating a critical infrastructure, and cybersecurity is for us was a national security problem. So I would like to give some concrete steps, some concrete security controls that we continuously implement, that can give some idea to security researchers here, to also some security experts that have similar problems. For securing telecommunication networks, for mobile network, you have to secure SS7 and diameter protocols, for example, and you have to have firewalls in place. I mean, if you don't put a SS7 firewall, for example, one can reveal your location information remotely, and you must have a firewall for this protection. At Turkcell, we have implemented our own SS7 and diameter firewalls. Also for SMS, we have our own implementation, because we thought, okay, we don't want to use a foreign product. This is a national security problem, and we have developed these products. And last year, we implemented the automated penetration testing tool for SS7 and diameter protocols. So again, for cybersecurity, it is always a process. It is always a continuous task. Therefore, we need some automation tools, and for SS7 diameter components, we implemented this. Vulnerability management, I put vulnerability management always the #1 task for cybersecurity teams. I would like to highlight this with some concrete numbers. There is a global vulnerability database. It is called NVD, National Vulnerability Database. Everybody knows this database. Everybody actually aligns with this database, this vulnerability database. At the end of 2023, there were 28,000 vulnerabilities in this database, and this year, at the end of this year, it is expected that in the NVD there will be more than 40,000 vulnerabilities. That makes every day we have at least 25 vulnerabilities to deal with. So you have every day, including weekends, every day your team must focus on these 25 vulnerabilities and check if you are vulnerable to, if your assets, your service applications are vulnerable to this web application. It's a very complicated, and it is becoming much more complicated. For example, every month there are more than 30 vulnerabilities whose risk score, CVSS score, is higher than 9.0. So, and for half of them, there exists an exploit. That means if this exploit is used, then your applications, your service can be then gained by unauthorized people. So therefore, vulnerability management, including vulnerability intelligence and mitigation of vulnerabilities, is really a very big headache for big enterprises, also for telecom operators, and we have a dedicated team for this process. Attack surface management is a very hot topic, especially in the last 3 years. Automated attack surface management. We were doing this manually for several years, but automated attack surface management for access network and for core network is very critical. We are performing this attack surface management, especially for detecting security misconfigurations and detecting for over-privileged access lists. This is also a very critical issue. DDoS protection, as operator, we have to provide DDoS protection for our systems and for our enterprise customers as well, and especially for internet-facing core network equipment. This is becoming a very complicated task as well. That's what we also focus on. Of course, there are always new technologies. When new technologies arises, and you have to focus on the security of the technologies. If, for example, if you look at the last 1 year in 2024, I would say, IP version 6 security, eSIM security, and currently in Turkey we have 4.5G, and hopefully we will have 5G soon, and we are focusing on especially 5G security, private LTE security, and also the private 5G security as well. And in the previous talk, the presenter, the professor, said that 6G will be beyond communication. It is communication. It is more application, services, machine learning as well. The mobile networks is also becoming very much enterprise-related IT networks as well. Therefore, virtualization security, because today we talk about telco security, virtualization security. Virtualization security already has become very much critical as well. My last point is about the device security. At Turkcell 3 years ago, we established a device security lab. In this device security lab, we are performing the hardware security tests, penetration tests, as well as firmware penetration tests, especially for IoT devices. We are delivering modem devices, access points, superboxes to our customers. We are performing the penetration tests, hardware, firmware tests of these devices as well. Also OT security. Within our data centers, we have, in the operational technology, we have the SCADA system within our data centers, and we are performing the device security issues as well. So securing a telecommunication network is very complex. There are so much additional tasks and challenges as well. But I would say these are the main points that we focus on. Yeah, thank you.
Thank you, Dr. TATLI, for the great explanation. Now it comes to Mr. Mahmut KÜÇÜK, who is the Cybersecurity Director of Türk Telekom. Mr. KÜÇÜK, with a total of 27 years of experience in the field of information technologies and cybersecurity, he has held various managerial positions in the finance and communication sectors. He not only implements the cutting-edge technologies and standards to protect our nation's critical communication infrastructure and customer data, but also leads initiatives in cyber resilience, maturity assessments, and attack detection, response, and prevention for a diverse clientele, including public institutions, organizations, and private sector companies. Mr. KÜÇÜK, would you please tell us about cybersecurity solutions at Türk Telekom, and also when it comes to cybersecurity, hardware security is also important here. What are your efforts on the hardware security side also? Thank you.
Thank you, Mr. Professor, and dear respectful guests at the end of the day and events. Thank you for your patience. I don't want to explode your brains because of spreading lots of, informations and different topic and such kind of, explosions, anything about the cybersecurity. So, cybersecurity is a concept. It's relies on the risk management. So, risk starts from the birth, and when you are alive, it starts, and risk management is, surrounds us, our lives. So we need to deal with all lifelong. So we have to manage our risks also in our countries, in our enterprises, in our all organization. So we need to define the risks first of all, and most of the thing, lots of people thinks about the national security. There is no nations as we can imagine in our digital world. There is no Turkish nation. There is no Arabic nations. There is no individual nations. Nations are technology producers. So nations are the technologies who produce, who manufactures the technologies. If you don't manufacture or if you don't produce or develop your technology and your applications, your hardware and software, building your environment, technical environments, you cannot build your nation. So, to building nations are first for our country and our nations. Being able to, in digital world, most of us using the social network, and our nations are X or Instagram or something like that in digital world. So, and when we talking about the protecting and safety in digital world, because the physical world safety rules and the principles are different than digital world. Digital world, those rules and games are changing, differentiates than the physical world, and we need to understand the digital world's, the rules. The main rules of the digital world is the producing and maintaining and managing that technologies, and the administering, let's say, not just administering. You can touch, you can shape, you can build, you can customize everything else. So when when you're depending on the other technology producers, you need to let's say trust them, and that trust might be used for different purposes, like data breach, some attacks, or some using as a weapon of that technology instead of against you. So that's why the producing is and the building your technology is the first to being in digital world. So with the transforming devices to the smart devices. I mean, it's a new strategy and new risk area of the digital world, and the nations are increasing the protecting critical infrastructure from cyber attack. I mean, that topic is much more important for the nations. And in global security surveys, cybersecurity risks consistently emerge as one of the most pressing concern. Like, you know, lots of insurance companies, like, you know, alliances, you know, the risk parameter report says cybersecurity risks are one of the top of the risk of the countries, you know, in subject of the risks. Since 2009, we have, you know, as Türk Telekom, with the cybersecurity solution we need to provide to our enterprise customers and nationwide. We need to monitor the emerging threats and trends and giving cybersecurity services. Operating within the ecosystem that serves both public and private sector, nationality and internationally. Our network extends across all industries with particular focus on critical sectors such as energy, finance, telecommunication and e-commerce. To safeguard Turkey's data, we continued investing in our cyber homeland vision. And we, to decrease our nation's reliance on important hardware, software and licenses, we actively developing domestic and national products and fostering partnership with domestic manufacturers. As I explained before, manufacturing your cybersecurity product is the most important thing in that topic, in that area. Türk Telekom Cybersecurity Center boasts the largest protection capacity in Turkey, and we support our customers with a team of over 200 expert engineers. Driven by our vision to utilize domestic and national products in critical infrastructure, we have invested heavily in R&D to localize product. This has led to a significant increase in our cybersecurity localization rate from 26% to the 65%. Our SOC, Cybersecurity Operations Center and Blue Team provide monitoring, response, SOAR, SIEM and EDR services. Additionally, our Red Team offers penetration testing, vulnerability scanning and management services. At Türk Telekom, we go beyond just developing innovative cybersecurity solutions. We ensure that the cybersecurity we ensure the security of both software processes like attack analysis and underlying hardware. Hardware security is just as essential as infrastructure and data security. To ensure this, we conduct through security testing on devices like modems and routers in our laboratories. The latest IDC cybersecurity market analysis reports confirms our position as the market leader in category cybersecurity, category of cybersecurity services for the third year running. Notably, Türk Telekom has achieved a significant milestone by becoming the sole institution in Turkey to earn accreditation from the international certification organization CREST in 3 key cybersecurity domain. We provide cybersecurity services that meet global standards. Thanks to our team of experts, we are decided to increasing the use of locally developed product and broadening our range of services in this field. Thank you.
Thank you, Mr. KÜÇÜK, for your explanation. Thus, we have reached the end of our panel. Would like to thank all participants who attended to panel, as well as express our gratitude to entire organizing committee that made this conference possible, including the rector of Medipol University, the heads of engineering departments, and the institutions and companies that sponsored this conference. Thank you all.
We also would like to thank you all for your insights about cybersecurity, which is a very hot topic. I'm sure they have questions, a lot of questions, but I think it's a very sensitive topic at this point. So to save you from any statement, so we're not going to take questions. I guess you can understand the situation. Okay? All right, thank you. Hediyeler geldi mi?
Geldi hocam.
Geldi mi? Tamam.
Önce panelistlere vereceğiz, sonra
Evet.
RadioFEST.
Tamam, okay. We have some gifts for our panelists. We're going to present them to you. And maybe our president will give you the gifts. President of BTK.
Sana izin vermeden de sen girip şeyden sonra.
Nasıl yapacağız? Beşte başlayalım mı?
Beşte.
Şimdi beşte başlamamız lazım yüzünü çünkü. Tamam mı? Ödülleri verelim. Biraz bekletiyorum ben Mehdi Hoca'yı. Sen bekleteceksin.
10 dakikamız var.
10 dakikamız var. Hediyeleri verelim.
Tamam, başlayalım mı diyorsun?
Marwan bir şey değil, çok vakit yok.
Tamam.
Birinci ekip, ikinci ekip, üçüncü ekip. Birinci hediye başka bir hediyesiz, üçüncü ekip. Tamam. Üç ekip. Benim hakemleri duyursun o zaman. Hakemleri duyursun değil mi? Şöyle.
Siz de duyurabilirsiniz hocam. Hediyeleri verelim.
İsterseniz sunumu yapalım. Yani sırayla çağırıyor, sesleri karıştırmayalım. Şey yapalım, uzatmayalım çünkü çok şey yapalım. İstemediler mi polisler? Onlar mı istemedi?
Yok hocam, siz aslında söyleyince sonra.
Ödülleri sen mi şey yapmak istersin? Birinci, ikinci, üçüncü soru sizi anons edersiniz, tamam mı? Birinci, ikinci, üçüncü. Zaten karar vermişsiniz herhalde değil mi? Şu birinciymiş herhalde. İkinci, tamam. Size veririm ben mikrofonu, siz şey yaparsınız. Ondan sonra ödülleri de kim verecek?
Onu işte sizi...
Şöyle düşünmüştük. Üçüncüyü siz verirsiniz. İkinciyi Hüseyin hocamız. Birinciyi de BTK.
Tamam. Tamam. Çok teşekkür ederim. Ayaklarınıza sağlık. Sağ olun.
BTK Başkanı Aryan o vermesi. Hediyeleri 3 tane verilecek ki hocam. Üçüncüyü siz isterseniz takdim edin. İkinciyi Hüseyin Hoca, birinciyi de BTK Başkanımız için konuşsun. Gidiyor mu? Başlayın isterseniz.
Now we are going to announce those RadioFEST winners, actually, 1, 2, 3. Actually, all of them are winners because they had the courage of preparing that demo and making the presentations, going through all the hard work. So in my heart, all of them are winner. But the ULAK team actually evaluated these demos, these projects actually. And it's not me actually who makes the decision. I think, you know, many of the ULAK employees, they went through all these demos and then they ranked them. So I'm going to let Zohair to announce those winners.
Okay. Thank you very much, Professor. It was hard decision, as you know. All of these projects was very, very good, actually. So our jury team had a very hard work for that. So I'm sorry for the guys that did not enter to first three. So I'll be announcing, and then we will present their gifts. Third one, I'm starting from the last one. Third one, Sadık Iqbal. He is real sense tracking, passive device free object localization and tracking.
So what was the project? If you
Okay,
it was location and position.
Location and position and tracking.
Tracking. Precision location, precision tracking. Okay. Okay. So where is the gift? Okay. I'm wondering about the gift as well. Wow, that's a nice one.
Congratulations to you, Sadık.
Thank you. So our president is going to give you the gift. Okay.
Now we will be presenting second one, Senanur Demirci. For her excellent work, VTX, physical layer authentication using AI.
Oh, there is this one as well. This is a gift as well?
Yeah, sure.
Oh, sorry. You forget about this. What is inside, Sana? Huh? I'll take a look while you are taking the pictures. This is a nice bag. I want one.
Okay, sure.
Sana bunun içinde ne var? Ben merak ediyorum. Yok bana hediye etme. Bana da gelir mutlaka. Okay, let's see the first
So
one.
the first one, the winner first of one, is Badreddin and Riyah Ozan. They have excellent work for location-aware adaptive relaying for IoT devices.
Okay, congratulations, Badrettin. The gifts are the same for all of them. Or shapes are different. I mean, these are looks like the same gifts for all of them.
Just it's for the first place.
What do we have for the first place? But it's a nice gift actually.
Quite heavy.
Yeah? And a bag, I guess.
And a bag.
Bags are the same as well?
Yes.
Okay. 2 bags for the winner? Huh?
There's Ozan also.
Ah, okay. So
That's
bags
good.
for both of them. Okay. All right. Okay. Okay, together.
photo, yes,
Together. Yeah. Okay. All right. Also with our president as well. Okay. Tamam. Siz çekilin oradan. Siz çekilin. Siz kazanmadınız ödülü. You move away. Your turn will come.
Ben geleceğim.
Ha, tabii o da gelsin. Okay. Congratulations again.
Congratulations,
Başkanım, çok teşekkür
and
ederiz.
And also for other guys who was in competition, please come. Can you come to stage? Fikir,
We all have pictures with you.
picture and little gift.
Oh, little gift.
Fikir Üledi, Salim Yahya, Yunus Emre, Katya Kenza. Please come to stage.
By the way, these bags are very high quality actually. When I go to conferences on these days, they give, like we pay $1,000 for the registration. They give a bag. Actually, I usually throw them away. I don't even bring them back home. But these are good ones. You get the message, right? Huh?
Thank you, Professor. It's a Kim bag. It's our new logo. Kablosuz iletişimler mühendisi.
It has your logo.
Yes,
Okay.
we started
All
using
right.
in Technofest actually this
I like
bags.
to be in the picture as well, and after that we'll have a picture of all together. Okay, let's have a picture of
Have a picture of all competitors, please come.
Sena, come. Bedrettin, where is Bedrettin? Leon, come quickly, because we are going to start the other sessions.
Hocam, I would like to invite all this team actually to Technofest for next year because they have very excellent talent for communication and
for competition.
Competition, right.
Actually, they really work very hard, and I saw them. I mean, they have been working on this over the last 6 months. Some of them were crying even, so I myself went through a lot of times actually to consolidate them, to calm them down. So, but finally, they made it. Thank you guys for your hard work and for your patience. Okay, I guess we are gonna start the next session. The time actually, what can we do? No break. So today is like one of those days. Tamam, siz başlayın, ben başkanımla
Keynote'a geçecek şimdi.
Şimdi olmasa da sanki.
Let me know when I can present. Hello, can you hear me?
Yeah, we can hear you. What about you? Can you hear us?
Yes, now yes. Perfect. Thank you very much. So let me know when I start.
Çıkar da şeydeki gibi nasıl çıkıyor abi?
Okay. Good afternoon, everyone. We have a fantastic lineup of speakers who are expert in both wireless communication and AI. Their insights and experiences will undoubtedly enrich our understanding of the integration of both AI in wireless communication. Now, without further ado, let's welcome our first speaker, Dr. Mehdi Benis. Dr. Mehdi Benis is a full professor at the Center of Wireless Communication, University of Oulu, Finland, and a head of the Intelligent Connectivity and Network Systems Group, ICON. His main research interests are the intersection of communication and machine learning in 5G, 6G networks. He has published over 300 research papers in international conferences, journals, and book chapters. He has been the recipient of several prestigious awards, including the 2015 Fred W. Ellersig Prize from the IEEE Communication Society, the 2016 Best Tutorial Prize from the IEEE Communication Society, the 2017 Eurosip Best Paper Award for the Journal of Wireless Communication and Networks, the All University of Oulu Award for Research, 2019 IEEE ComSoc Radio Communication Committee Early Achievement Award, and the 2020-2023 Clarivate Highly Cited Researcher by Web of Science. Dr. Bernice is a specialty chief editor for data science for communications in the Frontiers in Communication and Network Journal and an IEEE fellow. Welcome again, Professor.
Thank you very much. So may I just start, right?
Yes.
Thank you so much. All right, so very excited to be with you today. Good afternoon, everyone. So I'll be talking about this fundamental and important topic of semantic communication. I'll basically be presenting some, our visions on this, because this, as you will see, means different things to different people. So let's see how it goes. So quick outline, I'll start by a motivation, although the topic doesn't require any. And then I'll delve really into some of the technical works we've carried out in the area. This is the point-to-point semantic native communication. This is also about communication protocol, because in fact, this is very relevant for multiple transmit pairs or multiple robots, right? So they have to kind of learn signaling and maybe a language, right? And and then some conclusion. Very good. So I like to always start with basically what 6G has promised. Basically a lot of things. I don't think it has achieved maybe half of it, but that's fine. So it promised to bridge the digital, physical, and biological worlds. But we all know today that many visions today were just deploying more base stations, more bits per second per hertz. This is not sustainable, as we all know. Taking the 5G requirements and maybe multiplying them by 10 or 20 is probably not a good idea either. And of course, just taking AI and adding 5G and calling it 6G has issues, because we know today energy issues, right, of AI. We know it's brittle, it just does statistics, and I'll come back to it a bit later, right? So you can see this, of course, through many vision papers. So this is just one of them. Take your favorite KPI, multiply by 10, 20, you get 6G KPI. And one of the most important KPI actually is this one here, resiliency. I'll come back to it towards the end of my talk, because I think this is exactly where we should be drilling and thinking about more, okay? So in short, yes, 6G is nothing but 5G++ today, okay? So essentially this vision came to kind of challenge this by flipping the paradigm and asking two questions. First, I want to transmit less, not more. I want to think instead of just communicating, right? I need to reason about the other agent. And then I want to, in fact, to basically try to solve the use cases that 6G promised to solve, and it hasn't solved any, meaning the human-robot collaboration and so on and so forth. So in fact, in my case, I have already from day one based my research on how the human brains operate and how humans communicate. So some of you may know that there is this one system to approach in cognitive science, and it's been made popular by folks like Daniel Kahneman, psychologists, and it was picked up by AI. So today AI folks talk about system 1, system 2. System 1 is essentially the reflexive cognitive mode that humans have in their brain. That's the one that just learns statistical patterns from data, okay? That's exactly all the work you see today in AI, LLMs, semantic comm are here, okay? The one we are missing is the system 2, the one that is slower in nature, because you have to plan, you have to think, you have to do counterfactual reasoning, and ask the what-if question. What if I do this? What would be the consequence? Okay, and this is, in fact, what really should be pushed more in all our discussions, okay? And as I said, all the works today fall under System 1. In other words, they probably were already proposed many years back, but they now kind of reuse the word semantic, okay? So, of course, we know this topic sits at the intersection of communication. So obviously, everybody is familiar with the Shannon paper, right? Level A, level B, level C. I don't want to go again through this, but just to let you know, in fact, that for me, when I look at the 6G requirements, they are actually based on level A. And they do make sense, because, of course, Shannon back in the days removed structure, removed memory, removed all the semantics that actually we are talking about in this 2020 era, right? And something very important, in fact, is information in the Shannon sense, first of all, is different than the information that humans use, okay? So Shannon information is nothing but statistics. It's a statistical description of information, okay? And it turns out even Shannon himself told us, be careful. There is a very famous paper called The Bandwagon to use level B, level C. Of course, so everybody now is talking about level B, level C. But to me, I'm trying to formulate it a bit mathematically, right? I want to know what is meaning. what is understanding? And I think the right way, or one of the right ways, obviously, is we need to be talking about learning concepts and abstractions from sensory motor signals. This is level B. Understanding in the cognitive science perspective is really about learning internal models of the external world where the error is not calculated outside of the brain, but inside, okay? That is a fundamental way of talking about level B, okay? And then, of course, when it comes to communication, essentially, you need to talk about planning. As I told you, you need to have a world model about the other agent to model each other's intent or goals or beliefs, and then, of course, try to communicate, okay? Obviously, we need to also be talking about other type of mathematics because statistics is not what we humans use, okay? There is, of course, logic, and there is also, of course, other type of information I'm gonna present to you today, okay? In terms of information, yes, so we need to talk about not just scalar values like entropy of X, but of information shapes, information structures, right? And that's essentially my talk today, okay? And I'm sure the whole audience is familiar with the fact that there's a huge confusion today in what semantic communication means. For some, it's rate distortion. For some, it's compression. For others, it's deep joint source channel coding. I mean, you name it, right? There's a huge confusion for a good reason. So just as a spoiler alert, this is because these are all based on statistical notions of information, okay? This is one reason. Now, of course, what is semantic information? Well, for some, it's age of information. For others, it's maybe the cat in the cat image. For others, maybe it's the word-to-vec or LLM internal representation. But you need to know that these are, again, based on statistics. So you have to know that there is other type of information in logic. So there's this notion of set-valued notion of information from a logic perspective. There's also the notion of course, I don't want to dwell too much on this, but just to mention that if you talk to a logician, you will see what information means in that case, right? There is this notion of intention with an S. So intention, when I give you a logical formula, that's the syntax. The semantic will be the number of states that basically respect that formula, okay? But today I'm gonna focus on information as topologically variants and shapes. This is very important, right? And of course, how we can structure this information. Good. And just again, to reiterate the fact that channel information is not useful today for collaborative robotics. We have to be very clear about this. It's not useful for distributed LLMs. It is not, okay? Good. So on the AI side, I think everybody's familiar with the weaknesses. I don't want to spend too much on this. Yes, energy bill, sustainability, poor generalization. But you know, it's because it's all about statistics, right? Small data, big data. You're just doing curve fitting and trying to learn a model, okay? That's what we are doing today. And again, as I said, the system two aspects are missing: the reasoning, the extrapolation, the ability to adapt to unknown environments, right? This is really what's missing today, right? So we tried to come up with some kind of new desiderata that to enrich the current models. So of course, today they are based on number one and number two, meaning they are a function of the data, obviously, but they're also minimal and sufficient. So VAE, GANs type of models are based on this, but we need to add the elephant in the room, so to speak, which is really structure. So invariance is one of them. This is the ability to basically be invariant to rotation, translation, and so on, right? But of course, this is easier done in an image. But now if I give you a totally unknown environment, can you learn the symmetries from the data, okay? Disentanglement, of course, is also part of it, basically the ability to learn concepts and how they interrelate. And causality, we all know, again, that, of course, relying on statistical models is not going to be enough. We need really to talk about relational models, right? And also something very important is emergence. Emergence is a very, very important aspect because, in fact, when agents meet an environment, nothing is hard-coded. Information emerges via interaction, and so is the internal model, okay? So, of course, you could, this is basically what we try to do, is to learn now new models. And by the way, it's not going to be one model. Okay, we make sometimes this mistake. It's a category of models, a collection of models, all right? Satisfying the 6 desiderata here. And very important point is that we should abandon, when we can, supervised learning. We have to learn via self-supervision. The internal signal is what you need to be using to train your model, not the external signal or label by an external observer. That's why models today do not generalize or do not understand, okay? So now, of course, in an effort to unify a bit all the zoo of definitions and words and so on, I came up with this idea inspired from System 1, System 2, System 1 Semanticom, System 2 Semanticom. So System 1 Semanticom is 99.999% of all the work you see is basically, let's see, taking, for example, this is an age of information type of work. You have a sensor. Basically, the semantic information is the age of the packet. So we know, you want to receive the freshest packet at the receiver when it was generated at the sender. You could also take an image of a dog and then say, okay, I don't want to send the image. I don't want to compress it. I map it to a prompt, send the prompt to the receiver. Keep in mind that this is actually was proposed in a Huawei keynote in 2018, before OpenAI was known to the public, okay? So there's nothing new in some sense, right? Also LLMs, again, as I told you, these are just system one type of things, okay? Train a model, use it, solve a task. And of course, we know that it doesn't generalize because the model doesn't understand. It's not grounded in the environment, right? So system one is really just also kind of filtering technique or data. It's really compression, but in the data space. And some key takeaway today is really we need to talk about compression, but abstract compression. So one of the secret sauces of Semanticom is really semantic compression, okay? So system two, what is it? Well, you can look at it through the lens of the task. So the task here really is about planning and reasoning and compositionality. Compositionality is one of the most important aspects, the ability to piece together two concepts together, come up with a new concept and test it, like hypothetical action perhaps, right? So with that, you could look at, maybe new protocols for agents in a factory. Are these robots going to use 3GPP language? Of course not. So what's the language are they going to use from the sensory motor signals, right? And then other use cases, just for the sake of time, I will skip this. Now let's dive into some of the technical talks, the presentations or results. So the first paper, in fact, this is like 4 years ago now, kind of a toy example of what semantic communication meant. And you will see that these are still relevant even today. So what we try to do is to pose semantic communication as a multi-triangle model. By that, I mean, we have a speaker, we have a listener. The goal of the speaker is to abstract, compress his data, and send only the minimum amount of abstract concept to the receiver, such that the receiver can infer the intent of the speaker, okay? And in fact, here we were inspired by the triangle of meaning. So you can see here with me, this is the sensory data, okay? And that's what you try to learn concept from. So this is abstraction part, and then you can symbolize your concept. Again, exactly what humans actually are doing, at least to some extent, okay? And then, of course, we try to formulate this. This was actually a probabilistic reasoning type of thing. Again, how can the decoder or listener infer the intent of the receiver, of the sender? And you will see that this is actually an instance of communication compute paradigm, meaning that now the speaker can either send all the concept to the receiver or think about have a model of the receiver so as to send it the minimum amount of information, okay? So mathematically, this is very simple because in fact, back in the days, we were a bit naive in terms of what information means. So this is really just ray distortion in concept space. You see with me here? This is a cross entropy of the speaker's context P, the mutual context M. This is the entropy of P. So this is basically the compression part, right? So entropy of P divided by alpha, and likewise for the listener. So the goal really here will be about a kind of a dance between the sender and the receiver, because you can see here, if alpha is too large, so basically you will be compressing too much your information, meaning one concept, but then the receiver may not understand you, right? So you can see that there is a kind of a sweet spot here to be optimized, right? But from an information theoretic perspective, this is very well posed. You can actually even prove that this iterative algorithm converges to the mutual context of both sender and receiver, okay? There is some link to optimum transport for those who are interested. When you take few like uniform prior and the log loss, you can really formulate it in terms of entropy regularized optimal transport here and solve it using polynomial time sinkhorn scaling. Some of you may already be knowing that. And if that's violated, meaning it's not a log loss, this fails, okay? But in short, really, here communication is gonna be about belief transport, right, in a concept space. As long as we converge in the common space, we have actually communicated. So just some results here. So this is basically the reliability. These are your ray distortion parameter alpha and beta. Time, this is the number of self-iterations. So as you can see with me here, that conversion is very slow. this is slow thinking, right? Because in fact, this is a completely iterative algorithm from scratch. So if if you're constrained in latency, basically you're in trouble, right? Because the highest performance will be achieved only after 200 self-iterations, right? Because it will be here. So slower thinking is better. You can also the trade-off here in terms of communication rounds. Maybe you want to trade off. Maybe you want to communicate much more often than self-iteration. So you can see here that there's a nice trade-off. Let's say here for 200 self-iterations with 1 or 2 communication rounds, I'm done. I can actually already converge to the common concept. Okay. And then here maybe just some expected result, namely the compression gains here when you go from, let's say, system 1, when you send all the sensory information to system 2, you can see here you have massive gains, right? Because, of course, again, we only communicate concepts, okay? Good. So it turns out, in fact, that this is interesting, but it kind of was weak in the sense that we did not exploit really structure, okay? That's actually what we did in the follow-up work. We try to look now at this notion of semantic information defined on a higher order topological space. So now what we'll be assuming is that my data will be living in this k-order simplicial complex. So for those who don't know, so we are used to using k equal 0 and 1. So a vertex is k equal 0, right? And then it's an edge, triangle, tetrahedron, right? So in fact, sometimes information lives in this higher order simplicial complex. And now, of course, this is great because it gives me a topology and an algebra, meaning I can compose now different shapes, different triangles maybe, and come up with a new concept. I could do that, right? And yeah, so now next, so how do you operate on this simplicist? How do you do message passing? How do you do convolution? So it turns out, in fact, that there's already a nice theory called Hodge theory, which actually generalizes the Laplacian to kth order, higher order, right? So there's this notion of here co-boundary operator, which is basically going to track the information going from a lower order simplex to a higher order simplex. As you can see with me here, I'm trying to go higher in order so as to characterize the whole space where my information is. So how do you do that? There is this co-boundary operator here, which goes from kth order to the higher k order. And then the Laplacian will be just about moving this information. So you can see here it's kind of closed form expression. This is the adjoint, right? The kth order plus the co-boundary operator at the lower order, and it's adjoint, right? So you can do this. This is not difficult at all. And then, of course, for training your model or your weight here, for a given complex C, you have now the Laplacian here. You have to train these weights. Okay, this is actually what we have done in this work, right? And again, for validation, we took like a sender-receiver type of architecture. So again, the same concept is here, right? So the sender has to choose which order it has to go to in order to encode its data via this simplicist, right? And then the receiver has to also infer the data on the right order. Okay, so you see, you have to decode first the structure and then the function on the structure. That's essentially what we did. So just quickly some results here. Decoding first the topology, right? When I remove 50% of the data, this is, I think, a very fundamental result here because, in fact, all the baseline will fail. But here, because although I'm operating at a low SNR, and I remove 50% of the data, no problem. The receiver is able to infer the missing data because it knows on which kth order it has to go. Okay, so the higher order, the better. Okay, and likewise for feature accuracy here, you can see the same trend. Okay? In other words, even though I have missing data, even though I have syntactic errors, no problem. We can still solve the problem, meaning that the receiver can infer the data. Okay, because there is structure. Okay, so semantic communication is actually really about structure. Okay, good. So now let me move to maybe another interesting part of the talk is really about these protocols, right? So can we learn MAC protocols layer 2 using AI, but not in a naive way, okay? So here we'll do it using this notion of abstraction. But for that, of course, we had to see what was done. So it turns out that actually Nokia Bell Labs, Jacob Hoydis at that time, they tried to kind of relearn or teach the 3GPP language from a base station to a user, right? And to do that, there are not many ways, or maybe there are, I don't know. You can formulate it as a cooperative multi-agent RL problem, right? And you just throw your AI favorite policy gradient and solve it. Turns out that was maybe good back in the day, but now we know the mistake because this is not a good idea to do because you're learning in the wrong space. You're learning in an unstructured space, which is a state space. You see here, this is my policy. So of course you can it can work, but you need 1 million points. And guess what? If I change anything in the environment, you fail. It will fail because it has not learned anything. It has not abstracted, okay? So instead what we have done, we said, don't learn in the state space. Never do that, okay? You have to learn in the what we call information space or configuration space if you're a physicist, right? This is exactly the key component of semantic communication, okay? Oh, and machine learning, by the way. So what is abstraction? Well, you have a whole range of possible techniques from, are you looking for just compressing the cardinality of or the size of your set? Are you after some symmetry? Are you able to identify some invariance? So actually for us it was very basic. We just took a rollout of, so this is RL, right? So state, reward, action, and compress this information so as to extract a latent representation Z, which I can use to generate signaling, which I can use to try totally different crazy signaling and try maybe this is bad, this is good, right? So you can see here kind of a digital twin or whatever you want to call it, right? And that's actually what we did, right? And very interestingly, this is the baseline. This is Nokia back in the days, the baseline without abstraction. It fails after 2 users, right? The abstraction-based solution has no issue. Of course, it will go down after some point, right? Why it works is because you abstract, okay? Same thing here. You can see here, after maybe 6 packets here per agent, the performance drops. No problem with the proposed approach based on abstraction. So a key message today really for this topic and machine learning again is really the power of abstraction, okay? Good. Now another work, very exciting work. This is more theoretical work. Here we really were asking now, can we exploit different notions of information from algebraic topology? So we took a kind of nice setting here, which is a cooperative map discovery between 2 agents from sensory information. Field of view, we can see here. So a naive way will be to learn this protocol, okay? How can they communicate, right? To discover the map using the same machinery, a cooperative MARL or other techniques, right? Problem is, be careful because again, don't learn in the wrong space, right? Because there is no structure, there's no concept, you're just doing black box, it's not working. So instead of what we did again, this time we said, okay, we'll do the same trick, learn in information space, but now we're gonna be very formal. Now we're gonna focus on symmetries and deformations, because of course, there's a lot of structure in the environment that I need to exploit to compress. So yes, now I'm talking about compression, and I'll show you how we did it. Okay? So yeah, and of course, this gives me good grounding, actually very principled grounding to talk about level B of channel, because now meaning for me is not some sort of suitcase word here, but really meaning is about equivalence classes of data. Compression, I'm compressing in this abstract space, and then I can do my communication and whatnot, okay? Very good. So what did we do is as follows. So 2-state approach. First part is I'm taking my fields of view, you see them here, and I'm gonna form a quotient MDP with respect to some subgroup. Here, the subgroup is really about rotation, because you see here, some fields of view are actually equivalent, okay? And then you can come up with this nice formalism of MDP with the group G of symmetries, meaning that the transition and the reward are equivalent, you can see with me here, under the action of the group. What group? Is really just rotation in this case, okay? Now, that's step number 1. Step number 2, a much better compression is in fact to deform. You can see with me here perhaps that there are some fields of view that actually are deformed version of the others, meaning they are equal, they're equivalent, right? And that's actually the whole trick in this work, and I think it's valid for many topics. If you work on point cloud compression, this is the same idea, okay? And now what was actually very interesting here is in the fact that you can reuse what we call, there's this pipeline of persistent homology, basically taking point cloud data and compressing it such that you extract the semantic feature of the data. How do we do that? So you take, these are your point cloud, by the way. You take a radius R, 0.6, and as you can see here, as I increase R, there are shapes which are born. You see here, triangle is born. Then maybe it's dead, and maybe you have tetrahedron, right? So you see with me, I'm getting a barcode. This is my semantic information. I'm just scoring this fact here, okay? Because I'm compressing my data, right? If you didn't get it here, you see, this is a field of view, right? This is the death and birth. This is just another way of writing my barcode. So you can see with me here, you want, as a point cloud, as a feature, you want to be born early and die late. You don't want to be born early and die, okay? So this is the persistence of this feature. That's my robust feature. That's my semantic information that I'm going to use to learn a protocol, okay? So I hope this was clear. So that's essentially what we did here. So just in short, basically, to compress this original cooperative POMDP to quotient MDP and reduce MDP. And then there's a lot of work to be, that I can share with you here, maybe the archive, but essentially showing that this idea outperforms the non-structure based approaches if you use VAE, so it will not generalize, okay? Also, in terms of internal model, you can see here, this is the VAE. Everything is confused together. The persistent diagram type of kind of representation is much, much cleaner, right? And of course, there's some theory here I'm not gonna spend time on because of lack of time. Good. So now, of course, there's something else. Right now, in fact, I focus on state abstraction. Okay, but there's something else that humans have. I told you before, it's world models. World model is think of it as an internal simulator that we constantly use to run counterfactual questions. What if this? What if that? This is planning for control people. But here I'm talking about an internal planning, an internal model predictive control, right? And this is also one of the pieces that are not talked about much, but I think we need to talk about it. In fact, learning world models are about abstraction. So here the idea is you don't want to do generative AI. You don't want to reconstruct pixels. No, you don't do that. You want to learn semantic representations, meaning I give you an X and a Y, 2 images, 2 field of views, 2 point clouds, and you want to tell me that these are the same, although they look different, right? So there's a machinery here proposed by Yann Lequin, JEPA, for Joint Embedding Predictive Architecture, that does it for you, okay? This is his paper, so what you may be familiar with. In fact, what's striking is essentially that this proposed vision for the next decade, there's nothing new. In other words, this is just representation learning. This is planning, so multi-step planning, okay? But this is very good for us because we communication folks and control folks are actually using this, okay? This is just food for thought. Anyway, so there is today JEPA for text, there is JEPA for image, video not so much, right? So what we actually did in my group, we looked at it from a video type of setting in a remote control problem. So you see here you have frames, frame K plus 1, but it could be K plus 100, right? And the goal here really was to extract, to learn the semantic representation from these frames, right? Which is a sampling problem, by the way, first of all, and then share this with the server or a base station. And then the server try to basically predict, the remote robot or remote frame, okay? And now, of course, what's interesting here is that even though you may have packet losses, no problem. You see here, this is the few consecutive packet losses. This is the error, no problem. Versus a baseline, which completely fails as you fail maybe 2 or 3 packets, okay? But why? Because, again, we are exploiting this semantic information, okay? Good. Right, so yeah. So essentially what can be predicted should not be communicated. Syntactic error is no problem. And of course, again, we should not learn one word model, but a collection of word models and then maybe choose according to your, latency, reliability requirement. Okay, good. This is very important also topic. I think some of us are already working on this. Basically, a distributed semantic sensing and fusion 2.0, in the sense that now what we're dealing with is totally different senses with totally different maybe architectures or totally different syntax. Today, we don't know how to fuse information. We don't know how to do it unless you do it in a brute force approach. Here, we try to do it in a more mathematically sound way. Okay, this is this one for information. And finally, perhaps, no, sorry, there's my daughter in the room. So finally here, in fact, there is something I want to bring your attention to is resiliency. As I told you before, or in the opening, I think this is the key driver for 6G. So let me explain. So as I told you, resiliency is ill-defined today, means different things to different people. If I was in the room today with you in Istanbul, I would do the following. I would ask the crowd to actually define resiliency for me. And I'm sure you will see that many people will say, okay, maybe it's just reliability. Some people will say, oh no, actually it's robustness. Actually, it's nothing, none of those things. So here, I'm just here today to tell you what we mean by resiliency. This is a work in progress, and there will be a lot of works coming up on this. So reliability really is 5G, URLLC. So the ability to characterize the tail distributions, right? I think we spent a lot of time working on this as a community, right? So now we somehow know how to do it. But robustness is different. Robustness is really the ability to deal with known stressors. You already know in advance what kind of stressor you may have, and then you patch for it via min-max optimization, via some risk-sensitive objective function, right? So in fact, you're robust but fragile, because if there is an unknown stressor, you're failing, okay? And that's exactly where resiliency comes, because resiliency is about, of course, we know it's about bouncing back and recovering, but the very important point, in fact, here, this is an open-ended problem, meaning you don't know where the stressor is coming. You have to get ready. You have to kind of prepare your network so as to sustain this harm, okay? And of course here, unlike reliability and robustness, let's say unforeseen and bad events will always happen. Okay? And we know now we live in the era of, severity of this event. So this is a key concept that we need to be working on and take it actually quite seriously by first defining it, what's the metrics, and what's the foundation. And that's actually what we are doing right now in my group. So just to finish here, semantic com, I think, is a fundamental topic, but it means different things to different people. I hope today I convinced you of the right way, or maybe one of the right ways to do it, to look at it. So system 1, system 2 semanticum are not the same. System 1 semanticum is already done. It will make it to the standard. That's native AI. But here we're talking about something else, okay? We're talking about the technology that will enable autonomous driving to communicate, drones to communicate, and so on and so forth, right? And yes, we need to talk about agency, of course. These are not passive observers fed with data. No, these are agents, okay? Planning is key, as I told you, via world model, because you need to plan, predict the consequence of your actions before they happen, right? And yes, and information is not only Shannonian property, okay? That's also very good. That statistics is good. We need it. But there is the notion, of course, I told you, of invariance as shapes, as structure, and of course, depending if you are approaching it from logic perspective or from topological perspective, you have totally different notions of information, right? So that's actually what I wanted to share with you today. And maybe again, just to reiterate the importance of this beast here, resiliency, is really the right keyword to justify a new G, because other KPIs are just 5G. And with this, thank you very much. Let me just go back because I don't see you. Here we go. Thank you very much. Happy to take some questions.
Thank you very much, Dr. Mehdi.
Thank you.
For the enlightening presentation. We appreciate your insight and the valuable information you've shared with us. Now we'd like to open the floor for some questions.
Sure.
Thank you, Professor Benis, for the presentation. So let me first confirm my understanding of semantic communication. So basically, instead of sending information bits, we are trying to convey our message considering the context of whatever problem that we have. So if we consider it that way, for me, it's like for each situation, you kind of have a different, what we can say, compression or encoding technique that we're using to get our required information at the receiver side somehow. So if that is, my understanding is more or less correct, then the question that comes to my mind is basically from the interoperability or implementation perspective, especially from standardization, that if you have a lot of different possible contexts available in your network, so basically how do you make this feasible? Like for each application, for instance, or each use case, you are going to have a different context and a different, let's say, encoding or compression, or how is it going to work?
Yeah, good point, yeah. So, I mean, this is very easy, because in fact, industry is trying to do it today. So under the umbrella of interoperability, what's happening today, and I think it's a good idea, is, yeah, you will have a lot of pre-trained models for solving variety of tasks, right? This is offline, right? And then you come at deployment time, and actually now you would try to basically make these small models, or they don't have to be small, right? And interpret, meaning that they have to understand each other. How are they going to do that? That's essentially the semantic come here, because of course they may be trained on totally different settings. They may have totally different goals. So mathematically you can pose that. That's a kind of a distributed consensus problem, right? And actually we are working on it in my group. So that's happening. Of course, it's happening with industry engineering inside. So just software programming, right? But I think there is something underneath that as well, right? Especially when you have totally different syntax, right? Let's say a base station has a totally different syntax. Let's say Ericsson vendor and the Nokia, whatever vendor. Today, the logic is hard-coded, right? But now we want to automate that. How? You need to go via semantic communication. Now, of course, back to the first point, yes, every problem will be different. Every problem will have different structure, of course. So the beauty of Shannon was, in fact, that he removed all this and just did the, send X and get X hat, right? But no, we were operating like specific use cases. Take the collaborative robots. I mean, that's one. You will have robots in an environment, sensor information. And yes, they need to be able to sense the world and also model the other robots in the environment so as to essentially communicate, right? So, and that encoder, that compressor, sure, maybe is useless for VR use case, but that's not my worry. I mean, for me, I'm trying to develop the theory and maybe let you folks focus on the rest. But yeah, we are not talking about a universal compressor. No. It's gonna be a library, perhaps, of compressors which you can now compose all together to solve a task. Maybe that's actually what my answer should be, right? A library of encoders, compressors, that at runtime we try to compose to solve a task. By composing, really, I mean composing models, composing interfaces, composing agents, right? So that's actually how I would even answer it, right? Yeah.
So
hopefully this. Yeah.
So just to confirm, basically, as long as we are talking about application-specific cases, semantic is going to be much more practical and useful. But if you're talking about devices which have multiple purposes or a wide range of application, it might not be the way to go, at least in the beginning, until those devices are capable enough to handle, let's say, a handful of those contexts or compressors and those things.
Yes, I don't know if I got your point, but my point is semantic communication is a must-have for certain use cases which are clear. One of them is collaborative robots, distributed digital twin or immersive communication. You need those compressors, those abstractors. You need it for remote control. So basically, you need it everywhere. Today, and I think you know this, we do it at a application layer. So in short, so semanticum is already done when you talk to people working on video streaming. Okay, they do it. But now we're talking about something else here. We're talking about emerging languages, signaling from lower layers to maybe even application layer. And what's the mathematics that allow you to do that? That mathematics turns out to be about abstract compression, right? Or maybe a family of abstract compressors, right? That you would again use and compose. I'm really underscoring the word compositionality because in fact is the key enabler for interoperability. So interoperability of TGBP, if you want to map it to mathematics, is how do you compose subsystems, components, interfaces, right? So as you solve a task. So I mean, this is actually the right thing. And then you again, I will just stop here perhaps and just say it's of course use case specific, but yeah, my point was yeah, semanticum is needed everywhere. That's my point.
Thank you very much for the answer. Are there any other questions from the audience? Okay, here's another one.
Hello there. My question is as following. Can we implement this new type, at least it's new to me, the type of communication to current hardware devices, especially since, to me, I think it resembles a lot like edge computing.
Yes.
Can it be implemented? Also, another question, if it's well, if I can. Since this communication really extracts information from the data, what about situations where the context of the information kind of differs? Is there a way to make a threshold or something that can differentiate between this context and how to properly get the information from the data?
Yeah, very good question. So, okay, quickly on the first one, yes. So embedded. So currently in my group, we are trying to work on collaborative robotics, where we're trying to, in fact, run those abstract compressors on the robot. And it's not easy. Yes, it is very difficult, especially when you work with point cloud. But we are trying to go there and understand the requirements. But that's the goal. Yes, we want to do that because we know that's how humans do it. So we need to get inspired, right, and then see what happens. Perhaps do some offloading of some, the extensive kind of compute extensive tasks. But yeah, it's possible to do, right? We are trying to do it actually. So within collaborative robots, we want to basically the use case I showed, right? You drop in unknown environment a bunch of robots, right? And you want them to image or discover the map, of course, without going to the same rooms, right? So how can they develop this without being without hard coding who goes where? Okay. Another use case, maybe you can think of a bunch of robots in your home that you want them to clean your home, right? So where do they go? How can they solve this task? This is actually a use case we are trying also to go a bit towards. Now on the second point, how to distinguish between different contexts. I mean, this is actually falling under abstraction. So actually, abstraction, although it's a mouthful piece, there's a lot of mathematics under it. So in fact, what you could do, and maybe I'm gonna be even releasing a paper maybe next week or 2 weeks from now, is there is this notion of information lattices, which allows you essentially to take sensory information and partition it in such a way that you could actually, again, cluster similar information together. In other words, that actually gives you kind of a hierarchy of concepts, right? And then maybe depending on your latency requirements or whatever requirements you have, you pick a different partition in that lattice. Okay, this is how to differentiate between, but of course, if you have two robots with totally different understanding of the world, it's a problem. So actually, this problem is fundamental to semantic comm, because what you will have, as I said before, they will come with their own biases on what a concept means. Maybe this guy understands the concept red in a totally different way. The other robot understands concept red in a totally different way. How do you make them talk? So it's a fundamental problem, and there are, of course, mathematical foundations to do it. There are one, there's something called sheaf theory. I invite you to check it, or maybe you wait for my paper. But yes, basically the ability to glue together local information, although you may have you may have disagreement. In short, this is a theory of disagreement. It turns out that this theory exists today. A theory of disagreement. We disagree on part of what the world means as a world model or concepts, but we have to collaborate together. Okay? So actually, it is one of the very nice problems in semantic. Yes.
Thank you.
You're welcome.
Okay, then I would like to thank Dr. Mehdi Benis once again for his time and contributions today. And by the way, next year we are also hosting PMRC conference here in Medipol University, so we hope that we can see you in person in here. You're most welcome.
Inshallah. Thank you so much for the invitation. So I wish you a nice end of the day. Okay, and all the best. Thank you. Bye-bye.
Bye. Now we move on with our next speaker. Actually, like they say, the best is for the last. We have another experienced speaker who's also expert in wireless communication and AI, and who's also gonna share his insight and experiences within those two fields. Together, let's introduce Dr. Merwan Debah. Merwan Debah is a researcher, educator, and technology entrepreneur. Over his career, he has founded several public and industrial research centers, startups, and is now professor at Khalifa University of Science and Technology in Abu Dhabi, and founding director of the KU 6G Research Center. He is a frequent keynote speaker at international events in the field of telecommunication and AI. His research has been at the interface of fundamental mathematics, algorithms, statistics, information and communication sciences with a special focus on random matrix theory and learning algorithms. In the communication field, he has been at the heart of the development of small cells in 4G, massive MIMO in 5G, and large intelligent surfaces in 6G. In the AI field, he is known for his work on large language models, distributed AI systems for network and semantic communication. He received multiple prestigious distinctions, prizes, and Best Paper awards, more than 40 IEEE Best Paper awards for his contributions to both fields. According to research.com website, Marwan is ranked as the best scientist in France in the field of electronics and electrical engineer. He is an IEEE Fellow, a WWR Fellow, a Eurosip Fellow, an AAIA Fellow, an Institut Louis Bachelier Fellow, and a member émérite SEE. Welcome again, Dr. Marwan.
Okay, very good. Thanks for the introduction. I think your introduction was longer than my talk. So next time, I think you need to shorten the presentation. So I don't know if you see my slide at the moment.
Yes, we can see it clearly.
Okay, very good. So first of all, thank you for the introduction and extremely happy to give a talk here. Unfortunately, I could not make it, but I know that a lot of colleagues have been speaking before me. Dr. Tongwen from Huawei, and I've just saw that Mehdi was also giving a talk on some topics which are, I think, very important at the moment. So my talk is going to be about something I think quite important today, which has happened in 2023, and for which I've been working, to be honest, since 2021, related to this, I would say, big hype around GPT, and showcasing you the kind of things that you can do today with, of course, large language models and how they can impact today, basically, the field. So my talk is entitled Telecom GPT, Next Generation AI Powered Network. I think I didn't see the talk of Dr. Tongwen, but he has been at least showcasing you how this, of course, provides new opportunities for operators today by building basically large language model in their infrastructure. And to be honest, before I start my talk, I think it's also very important to highlight that we've been going through an industry in the last 20 years, after the big hype of, I would say, GSM with calls and SMSs, where revenues have been growing down year by year. And I think today we have a great opportunity to take back a big part of our share, because a lot of things are not really well understood. Why operators, on which basically the connectivity is there, are losing all the revenues to other companies, which are retailers and others. And whereas a lot of the things could run on their own network by providing, of course, new revenues, and this is the kind of things I'll be talking about, because certainly one of the things that is important related to LLMs is that, of course, it can generate new revenues, and operators can become the next generation platform, basically, on which everything can run. And this, I think, is very important. So a lot of the things I'll be talking about are in a series of papers. And again, whenever you do in your research, you always collaborate. And of course, you rely on the shoulders of giants. So a lot of the work I've been doing has been done with colleagues from, of course, Khalifa, but also the Technology Innovation Institute. And a lot of more detailed information about my presentation can be found in this series of papers. And also, more recently, also looking at more futuristic aspects around large language model and GPT architectures, which is at the basis of AGI. So I strongly encourage you, in general, I'm quite open basically in answering questions by email, but also, of course, putting all the papers and the knowledge that we're working on archive. So I'm talking to a public which is very telco oriented, so I think I don't need to go and spend a lot of details on that. But if you think about how the different generations have been going every 2 years, you could have this summary that I put in the slides. 2G, you could roughly tailor it as mobile for voice, with basically the KPI about basically having mobility for voice, and a couple of technologies behind which fulfill that KPI. And I think you all know them, going from GSM, IS95. 10 years later, we have another basically generation which appeared, which is called mobile for data. And again, behind that KPI, which is 3G, you have several technologies which can fulfill that, CDMA 2000 being one of this highlight. 4G came in with something related to having a wireless ADSL experience with mobility, and of course this provided mobile for internet. I want to insist on mobile for internet because I think all of you know that the people who have deployed 4G were so focused basically on having what we call a full IP type of network that voice was not working in 4G. And we all know that in 4G, voice is an application, not a technology. And by that, of course, we had a lot of problems during many years, by the way, to come up in finding a solution to provide basically great voice quality in a 4G network. A lot of operators were using a system called CS fallback, circuit switch fallback, meaning that whenever you made a call, you went on the 2G, 3G network. And whenever you browse on the internet, you stayed on the 4G network. Why I'm insisting on that? Because the application behind to provide voice and internet was called voice over LTE. And you have to know that already within 4G, we had the premises of using AI technology. And one of the key features which enabled to have voice with better quality within a 4G network was what we call AI-based voice over LTE. And in fact, it's in Turkey that a lot of experiments, you have to know, were done with Turkcell in trying to improve the voice quality by using this AI-based voice over LTE. And we used AI technique exactly because it was hard to understand how the packets were running in a network. And whenever those kind of approaches become hard, a lot of the researchers go to what we call data-driven approaches. In 2020, meaning that 4 years ago, we started deploying what we call 5G, which was tailored for mobile for things. Unfortunately, and I think all of you know about it, is that the majority of network are not deploying mobile for things, but more deploying what we call the EMBB scenario of basically 5G. And one of the reasons behind is, again, that we're stuck today in understanding how we make money out of IoT. At least operators are stuck in understanding how to make money out of IoT, because you can't make really money out of connectivity. And so you need to find new use cases. We hope that starting next year, we will come up with use cases on which we can find basically revenue generation, like localization, but also others, and where basically operators can take a bit of the share that they lost to these retailers, companies, which you all know about, which what we call OTT players. And now we're developing what we call a 6G generation. And what's interesting about 6G is that one of the things that we're asking ourselves, well, if you start deploying AI, and we're seeing it so massively in all the devices, IoTs, phones, tables, whatever, cars, and these, as Mehdi pointed out, starts communicating between them, is basically the 5G kind of standard capable of coping with such a massive number of devices which have AI enabled in them, and for which maybe the protocols that we have already in 5G are not quite adapted. By the way, these questions are always asked generation by generation. I worked intensively in massive MIMO. And when you think about massive MIMO, it has nothing to do, if you're familiar with that, with 3G, 4G, or 2G. You could deploy massive MIMO on a 4G network. You could deploy massive MIMO on a 3G network. You could deploy massive MIMO on a 2G network. However, a lot of people stamp basically massive MIMO as a 5G technology. Why do they do that? Well, basically because if you decide to implement massive MIMO, and we spend time on that, on a 4G network, you will realize quite rapidly that the signaling format in terms of uplink, downlink, limits you to the number of antennas that you can put in a massive MIMO system. In fact, what you can show is that within a 4G FDD network, the maximum you can is 24 antennas, dual polarized, which makes roughly 48 elements. And the reason, again, is because the signaling format does not enable you to estimate all the degrees of freedom that you have within a channel. And so we had to come up with a new type of standard called New Radio NR. And New Radio, of course, provides basically the capability that we had with the MATLAB simulation. And that is, of course, one aspect and understanding why, in general, when you come into technology, you need basically to change the standard to get the full basically capability of that. Today, the question is the same for people, by the way, who work on large intelligence surfaces. Large intelligent surfaces have nothing to do with 6G. You could deploy large intelligent surfaces in 5G. You could deploy large intelligent surfaces for 4G. You can deploy, and we do it today, large intelligent surfaces for Wi-Fi. There's a lot of good experiments. However, when you start doing the experiments, you realize quite rapidly that there's an inherent limitation in the signaling format of the standard, which does not provide you what you had in MATLAB or even from a theoretical perspective, and which basically then pushes you to look at what you need to change in the standard in terms of the frame structure, so you could potentially push the least limit to its optimal limit. And I think these questions for each technology that we invent have to be raised each time. Every time you start thinking of a new technology, you need first to start mapping it within a realistic environment, which is the previous standard, and understand why you're limited by that standard up to what you had from a theoretical perspective. And then you can start changing that standard, and especially the frame structure, the waveform, all the other things, to be able to push that technology. And so here we're having a bit the same when we start deploying AI. So let me give you 2 points on why there's a need of change of the standard to cope with this massive intelligence. The first thing, and Mehdi talked about it, but one use case is what we call compression. Today, when you have what we call distributed models, which are each point of the network, we start having basically a chat GPT talking to another chat GPT, if you want to go in the LLM realm, for example. And one thing, of course, that we're thinking of is, of course, to start building a network in which we don't need to have data which moves in a network, but more or less what we call the prompt. Let me give you just an example. Suppose you have a video and you want to transmit it on the other side. The other side roughly has the same model as you. So what would you do? Well, in a classical setting, you will take the video, you will compress it, basically with a classical type of basically zip, for example. You will send the data and the file which is zipped, and on the other side, you will dezip it to get the file. However, if on the other side you know that he has a model that can generate the video, you would do video to text, although you don't know in which language you will go, which will be the optimal way to compress it. But you'll do, let's do it this way, video to text. That text is sufficiently representative of the video because basically you can regenerate from the prompt the video. And then on the other side, what you will send is not anymore the video, but just the prompt or the text. On the other side, you'll do text to video, and then you can generate the video. So it's quite magic because within a system where there is a distributed GPT type network, you don't need anymore to transmit files, but you just need to transmit the instructions to regenerate the files. So if that was so easy, the story would be finished. There's 2 caveats in this approach. The first one is, of course, that we're looking at a system on which the end-to-end latency matters because there's a lot of critical aspects on which the video had to come very fast. And one of the things on which we're stuck is not just the transmission, but what we call the mobile edge generation. So if you had the experience basically of using ChatGPT or any other type of LLM model, you will realize that it takes a bit of time to generate. This is called the inference time. And so you need to come up with a mobile edge generation system, not mobile edge computing, but mobile edge generation with specific hardware, which can generate a number of tokens per second at a rate which is incredible to keep the end-to-end latency feasible and make this ID work. Second also, and I think Mehdi talked about it, is even though you send the instruction, you will not have necessarily the same video on the other side. But that's quite okay. Because when we communicate, if you ask me a question now, I'm going to give you an answer. If you ask me the same question in 2 hours, there's very few chances that I give you the same text, but I'll give you the same answer because the same wording, I'm not capable of giving it back to you. If you had the opportunity to use the systems of generative AI, especially ChatGPT, if you prompt the machine, it will give you basically certain text. Prompt the machine 3 hours later, you will get the same answer, but not the same text. Which means that we need to go out from the realm of what we call perfect reconstruction that we had, define a sort of semantic reconstruction, and Mehdi talked about it, on which it's just the meaning that we want to reconstruct, because at the end, it's okay if it's not the same exact movie, as long as the understanding of the story, the understanding of the whole picture is the same for the intended user. Coming up with a protocol which guarantees that kind of thing still requires work. And if you decide to implement it as it is in the actual standard, you have all these caveats that you need to solve, on which basically we have not built the system quite nicely. So that's the first point. Second point also, which matters, is the fact that we know that the future is going to be about what we call agents. There's no need today, by the way, in the next year to have apps in smartphones. By the way, in the last Mobile World Congress, which took place in Barcelona, Dutch Telecom already announced some phones which were totally apps free. Why? Well, basically, when you think about it, once you have an AI system, which is not anymore a large language model, but what we call a large action model, well, you could go beyond that. Let me give you one example. Today, if you want to book a car, you would take your phone, you would basically download a lot of apps, Uber, Careem, whatever. You will click on it, type the address, go back, take the things, make the payment, and come in. However, if you had a phone, you would need just a phone with a screen which looks a bit like ChatGPT, and you would just say to your phone, I want a car in 5 minutes down my house. Automatically, that instruction will have an agent. That agent will go and connect basically to all these basically other agents of cars. They will negotiate for you and come back. But this requires some kind of interconnected platform with extreme reliability and also some kind of latency, which is quite magic today. And the realm of building an infrastructure on which these agents live and where they should be, by the way, should they be on your phone? Should they be basically on a cloud? Should they be on the edge? And how they interact and how fast they interact is extremely important to build up basically the next generation system. But it tells you also that we're moving in an industry on which the notion of apps and app store that we have built to construct our system is moving out. Now, why all this happened and since when? All the ideas that I'm giving you. Well, 2023 was a key date. It was a key date, firstly, because it was basically the race of what we call the generative AI race. And as you know, and now it's every week that it's happening, there's been a plethora since basically the end of 2022 with the release basically of ChatGPT, with the release of what we call large language model with extremely high capability, depending on the size, how long they're trained, and the compute. Within the UAE here, you have to know, my group spent the last 2 years before going now in the telecom domain, trying to build the AI capability of the UAE by building basically a series of large language model, which is called the Falcon. They became quite known for a simple reason is that in March 2023, the Falcon 40B, and then in September 2023, the Falcon 180B, which is roughly 1 year ago, turned out to be ranked top 1, basically on Hugging Face within the open source. These large language models, of course, don't date back to 2022. You have to know that if you were in the field, and this is, of course, the kind of work that inspired me, knowing that, there was already a couple of models which were already in the market, and especially GPT-1, GPT-2, and GPT-3. So if you were in the field, there were already some models which were already there and giving basically the performance that we had. Unfortunately, they were all of extremely big size, and nobody really understood how to use them because the size was so big that only happy few could either train them or do the inference. However, in 2022, and by the way, this is what inspired our work, when we built Falcon, a very important paper was published, which is also, by the way, extremely used today, called Extreme Scale Language Models with Scaling Laws. And the paper was roughly saying that if you want to build a great model, the size is not the only criteria. You don't need to go into more and more bigger. Bigger is okay, but you have three factors. First is, of course, the size. Second, basically, is what we call the time you spend computing. The longer you compute a model, the better it is. And the third one is basically what is the kind of data set size that you can do. And today, the majority of stakeholders which are building what we call AI models, which are extreme performant, are playing on these things, meaning they train those models longer, they try to use high quality data sets to build them, and also look at parameters, which makes it that today we have models of the size of 3 billion, where we were talking about 300 billion 2 years ago, which are extremely better, basically, than the models of higher size. If you're interested in how these models are built, what kind of resources are needed, all the caveats that you need to avoid, we have a series of models that we have published called the Falcon series, and of course a paper that you can find on arXiv called the Falcon series of open language models, which give you all the details and tells you, of course, how you can train these models to get the performance that you need. Now, I'm going to spend 2 or 3 things to tell you how this is not magic. And what is the trick behind that makes the system work? Because, of course, my interest at the end is to see how these ideas that were mostly for conversation can be now applied in the domain that is of interest for us, which is the telecom domain. So you have to know that before 2017, and 2017 is roughly a very important day in the community, the majority of people who were working in basically NLP were using statistical techniques, basically, based on word to vec and bag of words, where wherever you had words, you try to map them and correlate them. A woman looks like a queen, a man looks like a king, and some things like that. And most of the techniques which we're using in NLP were based on architectures of the type like RNN, LSTM. And these architectures were based mostly on sequence-to-sequence modeling. So you could not scale, you could not construct big things. You cannot learn on big things because you had to go in a series. And so these 2 caveats, which are the fact that basically you could not scale, which you cannot parallelize, and you could not also learn long dependencies, were a bit of a hit to our community. In 2017, of course, a paper published by people from DeepMind, Google Brain, Google Research, and the University of Toronto came up with a paper called Attention is All You Need. By the way, that paper today, each one of the authors, I think, has a citation number of roughly 200,000 or 300,000. You need to check it. It's quite incredible. And basically, which for people who are here listening to me from academia is quite astonishing, because with one paper, you get a citation, basically index of roughly 200,000, 300,000. But they came up with an architecture called the transformer architecture, which is at the heart of the GPT. And that architecture, of course, solved the 2 caveats I was talking about. They can learn long dependencies, and they can parallelize basically what you do. So when we're talking about large language model, and if you never heard about it, what are we talking about? Well, the whole system is about what we call modeling a conditional distribution. I give you an example here. The capital of the United Arab Emirates is Abu, and I need to find what is the next word, the next sentence, the next image based on the input I put. So your whole goal is to know what is the property that X is equal to Dhabi, knowing that the capital of the United Arab Emirates is Abu. Knowing that is learning the P of X, this conditional probability. So learning a distribution is quite hard if you don't know where it lies. So if you go back to school, well, what they would tell you, if you don't know P of X, what you would do, you will do what we call polynomial approximation. You will say P of X is equal to A0 plus A1X plus A2X squared plus ANXN. N is the size of your polynomial. It's also called the size of your model. The A0, A1, AN are called the weights. Now, if you tell me that P of X has this description, then it's quite easy based on all the data to find an algorithm that minimizes basically some kind of mean square error to be able to learn all those coefficients, learn the property distribution, and then be able to predict any word. Of course, these kind of minimization or optimization techniques. When you optimize, you have to do a derivative. And of course, at the heart, there is an algorithm which is called the gradient descent. It turns out that we don't use basically a polynomial expansion to learn the P. We use another type of basis, which is called a neural network, because we have the tools to do it. But with that, I think you understood what we're doing. We're just learning a conditional property distribution to be able to get what is the most likely word that you can predict, what is the most likely sentence you can predict, what is the most likely book after your prompt, and then, of course, you'll take the most likely, which is called the maximum likelihood. Clear? And that's the magic behind. And you have to know that that's what we've been using to create the system. And these transformers are at the heart of that. We have the neural network to do it. And in general, to do all the training and minimization, we use basically what we call self-supervised learning techniques, and not supervised, which would require to label all the data. I won't have time to discuss what is being done now, because of course now people understood that these systems require a lot of energy. They have also a lot of caveats and coming up with new techniques, which goes beyond the GPT architecture. But if you're interested, we can talk about it. So that was, I would say, the first thing in 2023. And now for the remaining 10 to 15 minutes, I'll tell you how this has impacted our industry. Well, 2023 was also a very important date. And this is what I call the date for the kickstart of 6G. Because before 2023, people were doing a lot of things around 6G, but there was no consensus in being able to be sure that we will have one single standard, especially because of the geopolitics behind. 2023 was key for two things. The first thing that happened is that within the ITU, the ITUR WPD agreed on what they call the IMT 2030 framework. By the way, it's very important, and I'm talking to specialists here in the domain, that you need to differentiate 6G with IMT 2030, the same thing as 5G with IMT 2020. The right term is IMT 2020, IMT 2030. And we had this experience because if you remember in 4G, in the US, Sprint was claiming that they were deploying 4G, which is true because they had better performance, but it had nothing to do with basically the standard that we call. And now you'll see also a lot of people claiming that they have deployed 6G because it's a marketing term. So I think you need to be careful about that. In any case, in June 2022, we came off, of course, with what we call the trends, use scenarios, and the capability of IMT 2030. The second thing which happened also, which is quite important, is the fact that within the quarterly gathering of the community in the World Radio Congress, which took place last December in Dubai, gathered more than 1,500 delegates coming from 150 countries, we were already discussing the different use cases around 6G. And what came up, I won't talk about it, but I think you saw it with my colleagues. We have already been able to define what we call the KPIs in terms of latency, mobility, connectivity to enable this vision I was talking about. And of course, if you go more in details, today we have different stakeholders, and I think my colleagues were in the conference, trying to find what are the key technologies that could solve some of those KPIs. In my talk, I'll just go on the one related to intelligence. But if you're interested, today in the broadband connectivity, I've listed here basically the possible technologies that could make it basically with the standard. It goes from holographic MIMO to terabits coding, OEM, cell-free massive architectures, large intelligence surfaces, millimeter waves, LEO satellite, beyond WebDM waveform, ultramassive access, and time reversal. On the sensing and control, and some of the KPIs, especially for positioning, are there. You have joint sensing and communication waveforms, terahertz communication, wireless imaging, extreme RL, CH of information beyond sampling. And on the intelligence part, you have a couple of things that you could map in three parts. The first one is basically the work that we're doing to develop more and more models that can run on small devices. This is a huge headache because you have two approaches. Either you take a model which exists and try to quantize it, where there's some loss. Either basically you take the architecture as it is, which has a low precision because of your hardware, especially in IoT, and try to build basically a neural network and learn a model within that thing. These are called binary neural networks and others. You have to know that this requires a lot of sophisticated techniques from the comm society because a lot of these things are related to what we call basically combinatorial optimization, and the communication society is very good on that. Second is when we're building models, we're talking about a field in which we're not interested in text. We're interested basically in images. We're interested in voice. We're interested in RF, where basically you want to do things like RFGPT. I want to give the signaling format that I have, and then you do 3D imaging with that. And so you need to build multi-model models which can do that. I'll give you an example on some work that we've done. And the last one is basically building the infrastructure to let all these AIs talk to each other, considering at the end, again, the fact that as we humans, we're conveying the level B type of information of Shannon, which is basically what we call the semantics. You have to know to do that, I have launched basically with colleagues an emerging technology initiative within basically IEEE called the Large Generative AI Model, basically Telecom Initiative. I'm the chair of it. And we have several companies. You're, of course, very welcome to join and assist to what we do, where we have basically Apple, we have, of course, Ericsson, we have Huawei, we have basically a lot of different stakeholders, Intel, China Mobile, DO, and others, which are there to discuss what needs to be done. Now, I want to tell you a bit of the first work that we did in terms of building the systems. You remember when we talked about building the models which are necessary for the telecom. So the first type of things that we did is start to build up what we call a telecom GPT type of model, meaning that scrapping all the data and the knowledge that the telecom, I would say, operators, manufacturers have, so that we could build the best in the best model that could answer any question you can think of in telecommunication. It's a text-only type of model. We are now enhancing it with images. And of course, the goal is to have a multi-model which takes care of everything. On this Telecom GPT, the paper is online. You can take a look at it. So what did we do? We took all the data that you can imagine, which is over there on internet, going from 3GPP website to Huawei website, to things like Archive, to things like the LoRa lines, to things like basically that you can find with Orange on their website, open air interface. We did extractions, pre-processing, and then we did this task specification by defining also what are the benchmarks. You have here typically the architecture that we build of this training pipeline to do it related to the open telecom data set and going around. And at the end, we came up with some use cases for operators to serve them. The first one was basically, of course, providing use cases which enables enterprise knowledge. Here you have basically what Telecom GPT responds to specific questions. And of course, we benchmarked it with Llama, we benchmarked it with Mistral, we benchmarked it with GPT-4. And you can see in the paper, the scores are much higher than what you get on those models because it was extremely fine-tuned to that. So here, typically, you have a question. What does IM stand for and why is it considered desirable for constellation communication systems? The system gives you an answer. Index modulation is desirable for communication system constellation, and it goes. It understands what IM is. Second, you want basically to explain techniques, identify problems in the field where you are, propose solutions in telecom. An example, you ask the machine, describe the process of providing authorization to a mobile device for pending transaction request. The response of Telecom GPT. To provide authorization to mobile device for pending transaction request, the system searches, blah, blah, blah. You want to plan task in telecom specification to complete a high-level instruction. And you ask, initiate event-based charging with decentralized and centralized unit determination, centralized rating. It tells you, first, request for resource usage. Second, unit determination. Third, charging data request. So in terms of field technician, where you have a guy on the field, which is trying to solve the problem, he just needs to ask orally the machine and will get the answer to solve those kind of telecom. Second, you have basically some code on which you have some misunderstanding of what's happening. You prompt and say, analyze the script contribution to telecom workflows, specifying its primary functionalities. And it gives you a quite detailed answer. The scripts define a function BSC for binary symmetric channel within the telecom domain. It takes input bits, array of bits, and and all the description. Second, you need to do a patch. You need to do code. For my colleagues who are in academia, you need to build up a frame structure of a transmission while you tell. Develop a MATLAB or a C function that retrieves and returns the transmitted power value for a wireless device. The function shall be update a data structure, blah, blah, blah, blah. It creates you the code. And then for my colleagues here who are mostly writing papers, we decided to give to the machine the paper and tick off all the equations. We said we don't want to write equations. We just want to write the text and let the machine then basically finalize the paper with all the equation and the editing. And as you can see, we prompted the machine and told the machine, please fill in the missing mathematical equation represented by mask, placeholder in the provided section of a telecom relevant research paper that discussed the system model or problem formulation. And we start with, we consider a discrete time zero mean jointly proper Gaussian flat fading channel with the following input relation, and we put a mask. And as you can see in the response, he gave all the different right response. If you try it with, of course, GPT-4 and others, you don't get exactly that kind of accuracy. So quite impressive in what you do. Second step is going a bit further and saying, well, I don't want to have text only. My inputs or my prompts, because I'm in the telecom domain, are RF signals. So we released quite recently a paper on the 10th of July, 2024 called RFGPT, which is generative AI for RF sensing in IoT device. And the idea was to say, well, we have a lot of measurements related to a lot of environments. So for people who are in the signal processing community and working radar, this is obvious. Radars do that in some sense. You measure the signals and then you tell, okay, what kind of airplane I'm detecting? What is the size of the things? But what you would need is something quite automatic. You just get the signals and it gives you the right picture, color, and all the things of what's happening. And so we did experiments. We're having a lot of channel measurements with a lot of image environments. And we also added some synthetic data because that was not good. And running basically this approach of RFGPT, where we could go from signal to image and image to signal. So we give the image and it gives us the RF, basically propagation signature of that environment. And you get some very good scores, as you can see here, in this basically 3D imaging type of things. And now, of course, the next step, and I'll finish with that, on which there's still work to do, is, of course, coming up with the right kind of architecture that enables this real-time type of communication between different agents which are connected together, and where knowing where you need to place different of these tasks, and also making these agents solve some problems collectively. Because again, in general, you have multiple agents discussing together or interacting to do these things. And so I'll finish with that because for the time I have, for that case, you have to know that we started working on an energy reduction resource allocation problem, and in which we've been making these agents, which are on the mobile device and on the base station, collaborate to be able to reduce the energy for which we fixed some target. The work is still going on, and we hope, of course, to give you more insight on the results that we get basically in the next weeks with the papers that we'll upload around there. Thank you for your basic attention, and I'm, of course, extremely happy to answer questions to the audience.
Thank you very much, Dr. Marwan, for that amazing presentation. Actually, we do really appreciate your insights and the valuable information you've shared with us. And to be honest, as much as I'm happy hearing about all this telecom GPT, as much I'm afraid of losing my job, to be honest. But now I'm open the floor for the questions. Okay, we have one question there.
Hello, Professor Marwan. Thank you for your talk. So there are a couple of questions I want to ask. So first thing, in this large language models, whatever domain we are using, how do we ensure the trustworthiness of the model? Because typically, I think when you are collecting the data set, you are not able to filter out everything or check everything for how much confidence you have in that? That is one question. And the second question I just wanted to ask, this telecom GPT, is it fully functional and is it open for public use or not? What is the situation there? Thank you.
Okay, so for first of all, I'll answer for the second. The first one is more tricky, and we're not doing better than what basically ChatGPT or the community is doing. But on the second, we have of course released all the description. We are now in the work of releasing the data set, and there's discussion basically on, of course, open sourcing for the community, the telecom GPT, so you can use. When we mean open sourcing, it means that we don't release the code, we will release the weights, but that's quite enough for you to then run it and then improve on it. So these are still discussions that we're having with the management on that part. For the data set, this is something quite ongoing on. It should be in the next weeks, you'll get it, because we need it, of course, to make sure on all the choices that we made with the community, there's no issue. On the first one, this is a tricky question, and it's tricky at various things. Whenever, of course, you take the data and you start basically, of course, cleaning it and processing it, there are some decisions that you made which are related to what we call the benchmarks. What I mean by that is any model that you build, the first step that you need to do is define how you evaluate it. Evaluation today, you have to know, is, I think, before trust, the most difficult thing to define. How do you evaluate that the model is good? And I can give you the experience we had, because before working on Falcon, one of the reasons I moved in the Middle East, in Abu Dhabi, not to build Falcon, but to build what we call the largest language model in Arabic, which was called Noor. You can check it out. Noor is N-O-O-R. That was released beginning of 2022. And one of the things that we stumbled in Arabic was to say, how do you evaluate our model? Is it because it knows Quran? Is it because it knows all the history? You need to define a set of questions that basically, because once you define that, you do reverse engineering, the choices of the percentages of data that you're going to choose are going to be made such as you succeed those exams. Just like a student, by the way, if you want to get to MIT and you know that MIT is 30% mathematics, 20% physics, and these are the weights that are considered for you to succeed that exam, the books you're going to study are going to be tailored, such as you're going to spend already 30% of your time on mathematics, 20% on physics, so that you are in line with that exam. And then the choices is also going to be done. So first of all, before you do the trustworthiness, there's already a choice of saying, what are the benchmarks? By the way, for the benchmarks, we've been working, and we're working now with GSMA to basically start building a leaderboard with those benchmarks on which we all agree that a model which is good in telecom, if it's good, then it has to succeed and be able to do all of these tasks for us, okay? This has not been agreed yet because we sent, Huawei did it also with my colleagues of Huawei, we sent a couple of benchmarks and now the community is running around those benchmarks. But that's the first thing is you have to make a strict choice on the choices of data and cleaning data, which is based on the exam you want. If you tell me you want to succeed, for example, NYU, you want to succeed basically University of Turkey, I will do differently. Then, of course, the second step is the choices in terms of trust and bias that you'll get. This is something a bit tricky today, and we're not doing better than the other. We're, of course, taking all the data that you can find there with the percentage that we made, and then made some drastic choices in terms of, we think this website is not good, this website is good. So there's some work to do this thing in an automatic manner.
Okay, thank you very much for the answer. Is there any other question?
Hello, Professor. Thanks
Hello,
for your
Professor.
Insightful discussion. What's your thoughts about the limitation of implementing AI in 5G and RF, especially from the physical layer perspective? Like which future technologies can help us to overcome these limitations?
Okay, so first, I think there's two parts, and I think in the conference, I was not there, but I'm quite sure you talked about it. There's one thing which is about applying AI, applying LLM to 5G. This is, I think, not a problem. You can apply AI to Wi-Fi, you can apply it to 5G. I told you we did it for voice over LTE. for Turkcell a couple of years ago and applied it for improvements of the quality around there. And I think all those features can be improved with AI by applying that. Of course, the big questions you have in general is, of course, the consumption that you're running, the fact that where the models are going to learn, is it on a device or on the base station, which require basically, of course, different kind of features. But that is basically mostly for me, the classical trend. And we'll be doing more and more of AI for RAN to improve the radio access network. Where I think the biggest opportunities are for the telecom industry are two. The first one is building the infrastructure for people who are running AI, okay? So we are in the best position because the future, as you can see, is a lot of people basically having AI everywhere. The future will be also, by the way, you'll be walking, AI will be on the door, you'll tell to the door, please open, and the door will open. Because it's just at the end of an LLM, the door will have an embedded AI. You need to build a communication system where you talk to the door and the door just opens when you move, when you tell the door to move. So we're running in these things. And so the first thing is building these things. This is, I think, quite hard because there we have a lot of latency, short packets to build everything so that things can go at a very high speed, especially when there's transmissions, which are basically based on these IDs. The second, as I told you, is the inference part. What I mean by that is, of course, a lot of people will be using our infrastructure and we can take back the share that AWS, Azure has been doing. I'm talking here, if there's some operators, I think you have now a very, very well, basically, opportunity today to become the platform on which a lot of things can run. For example, when people make calls, today, why would the call and the AI which runs the call to do what we call call summarization run basically in AWS? It could run on the infrastructure of the operator. Second, you have great latency. Imagine AI avatars that you can do. And these can have to run on the edge. And so there's a lot of revenue generation that you can build basically on the fact that AI will be running on your infrastructure. And you could sell some subscriptions which are related to these AI features that you're enabling for your customer, which are avatars, which are basically a summarization of all the processes which are running on your infrastructure by having the compute. So going back to you, we would need basically compute which goes at a very fast speed. Today, the hardware is becoming more and more specialized, you have to know, for the inference. We went out from the idea that GPU and NVIDIA does everything. GPU and NVIDIA is very good for training. But we realize when you want to do inference, you want to generate specific type of files, and you want that speed. We have now people who are working basically on things which are related to what we call IPUs, inference processing unit, or large processing unit, on which you guarantee basically first the latency and you guarantee the speed. And I think this is also very good for us because we're going to go more and more on specialized hardware for the part where you serve the customer and not just basically the training. The training is another story.
Okay, thank you for the answer. I myself do have a few questions for you. First of all, regarding the power consumption, like training AI model consumes too much power. But if I use the model offline, then I can say that there is a trade-off. I used too much power for training, but now I'm using it offline. But this is not the case in telecommunications. You need always to be training your model. So with this energy constraint, do you still see that AI is going to be a dominant technology in 6G? My second question is this. We used to think that data is infinite, but now I think we believe that data is finite and the new data is also correlated. So what are the future challenges related to this? My last question is, we are fortunate to have a really good keynote speakers in the first days of the conference from the biggest players of the telecommunications sector, such as Ericsson, Huawei, ZTE, Nokia. Interestingly, all of them, they had a different point of view of where the AI is going to be implemented. Someone say in the edge, someone the network, someone the physical layer, someone impossible in physical layer. I can understand that each one is representing his company or the direction of the company. So as an unbiased researcher, I need your opinion. Like, where do you see AI in 6G? Thank you.
Okay. So the first question related to consumption, which is, I think, the key point today. First, on the trend, and then the telecom sector. Today, from my point of view, the next winter of AI is energy. What I mean by that is that AI, as you all know, is not new. It started in 1956 with this famous conference where all these top guys settled down. And of course, one of our leaders called Shannon was part of that. It progressed quite rapidly, then went down. 70s, 80s, we came up with expert systems, came up, and then down. And then basically, of course, the deep neural network arena went up, mostly because of the computing. By the way, up to the transformer, the majority of algorithms that we're using today are based basically on what was done in the 90s. And of course, compute is all you need. If you look at the announcements which are made today by companies like OpenAI and others are totally crazy in terms of consumption. You have to know that Microsoft now is considering nuclear plants to power their data centers because of the energy which is required. Second, the water which is required to cool those systems is totally nuts. These companies are now looking at places where you could basically install data centers for cheap because of the energy usage. Unfortunately, this is not just a question for AI, for my colleagues here. You have to know that in the last 10 years, I think we haven't spent too much time, and this is a professor which is speaking to all of you, in terms of being more intelligent on how to do smart things. You take Bitcoins, blockchains, all these techniques are based on brute force. Same thing, by the way, by the progress of LLM. We're just doing brute force, by the way. We're not inventing something new. We're just testing all the possibilities that you can imagine to get the solution. It's data-driven. And so, of course, this poses a problem because we know that the more we scale, the more we consume, the more we're going to be better. So it's quite magic at the moment in our industry is that if you give me more money, I can be better than you. Okay? I know that that's a path. Taking the path of thinking hard on how to make energy efficient systems is really a risky path because you will lose a bit of time, and time is key here today to take a competitive advantage industry. If Ericsson or whatever company spends time to do more energy efficient systems, well, they may lose 6 months, 8 months, 10 months. And that is super drastic with somebody who knows that if you give me more money, I can give you more models. Typically for all of you guys, if you give me $1 billion, I can do a very good model. Not because basically I'll spend more researchers, I'll just spend more compute. I'll buy more GPUs and launch into and scale the system. There's a bit of tricks, but that's not. So first of all, on your question on the energy, this is a key, I would say from my point of view. Of course, the fact that we decide to go more or less on the cloudification and trying to look at how we can do distributed systems, which are learning on site, and then with all these ideas of federated learning, I will say will be key in the future instead of bringing everything on a super compute center. But I think it can be the next winter because of the fact that we all now are going on a brute force approach. So I think this is a bit of an issue that needs to be solved quite rapidly. I'm quite pessimistic that it will be solved by 2030, you have to know. Because today we are in a race of, if I have more compute, I'll be number one and I can kill you. Second question, data. That's a good question. And I have a very good paper which looks at what we call model collapse related to that. You have to know that the studies are showing that by 2027, 2028, we'll be eating all the data that is out there. And this seems quite surprising. Well, not so, because we've been doing some studies where all the data was counted. And then, of course, some models showing that all of you are writing less and less, which means that the content which is on internet is less and less human generated. And so what it means that the models that are scrapping data on internet today are scrapping data which is AI generated, okay? You see LinkedIn, for example, all the posts of my colleagues today, they don't spend time writing them. They just say to a prompt, and then you have your post, LinkedIn post, which is there. And so the question is, how does a model behave if you learn on data which is AI generated? So we studied that. You have what we call model collapse. It means that if you learn on data which has been AI generated, the system cannot improve. And from an information theoretic point of view, this makes totally sense because you're not going to be increasing basically the knowledge because you're learning on yourself. And so there's a question of how we can still scale basically with the fact that by 2028, we are getting a limit, which is basically scrapping everything. And second limit is people are not writing. By the way, this is a good message for people because it means that machines can only improve as long as there's humans, because humans are the one generating unpredictable data. If they're not there anymore, there's a limit in terms of how the intelligence can go. Now, unfortunately, the studies today have been done mostly on what we call data, which is text only, but not the world in terms of the images that you take. And the question is, of course, how multimodality, and by having machines which can see the environment with sensing typically, could that also, the RF, for example, increase these models? This unknown. But if you want to do on data, we have, of course, a limitation, and we're arriving to a plateau, which is going to be a bit of a problem. And the fact that you build synthetic data is not providing us what we need. So this is quite unfortunate today. On the last point, this is something where we're all fighting today. I think the cloud perspective is, for me, going to be dying a bit from an unbiased point of view. And basically, workloads are going to be more and more running basically around you, meaning on the infrastructure which is built around you. So, of course, the edge, I think, is going to be a big part of what we're doing. And I think also it's the sense of history, because basically when you think of how the systems and we humans are built, all the knowledge of our brain is not centralized, all of us, towards somewhere, and then everything is taken as a decision. We humans, in terms of how we are constructed, we have a very massive 8 billion brains distributed in humanity, and it's within the interactions that basically things are working. And I think this edge distributiveness is what's going to be happening with the fact that you can build the protocols to connect this intelligence, which I call collective intelligence, not centralized, but very distributed. And again, I want to push this message for my colleagues who are more on the operator side. Because of this fact, I think you are in a position to bring connected intelligence to its maximum, because you are bringing basically the connectivity, and basically you're close to the latencies which are required, and you're not going so far to build it.
Thank you very much for the answer. If there is no further question, then I would like to thank Dr. Merwan for, again, for his time and contribution today. And I would like to tell you that in Istanbul Medipol University, you have a big research group, over 50 researchers. So we'll be very pleased to host you here and have you face-to-face in physical with our researchers. They're eager to know and learn, know you and learn from you as well. Thank you.
Thank you very much. It will be a pleasure to go to Turkey, and I have very close colleagues from Turkey, so I'll be more than happy to spend time with all of you. It's a real pleasure, and thank you for organizing also this event. I think it's very important also to bring the community together.
Thank you. Have a nice day.
Thank you.
Thank you all for being here today. I hope you enjoyed the 6G conference, and by this we end our event. Have a nice day.